उसको भी so that also we need to do it using DynamoDB. मतलब
नहीं
उसका
नहीं
अगर
नहीं 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 write it on your मतलब on मतलब write your own trigger framework.
okay,
Like
so
how would you
इसका
do it? How would you?
right,
हाँ,
so इसका अगर डिस्कशन कभी रीड करना हो हमें, so will we get it in your blogs also कि आपने इस पे कुछ लिखा है क्या
मैंने
ब्लॉग
कभी
सिस्टम?
लिखा नहीं इसके ऊपर, but it's very easy to build it. You'd have to do it on the application side. So typically यहाँ पे the things that would be tested would be your low level design on how you can create abstraction so that like you just make change at one place, like similar to how DynamoDB guys would have done it. Right. So this way you'd make change at just one place and it should start capturing all the triggers, or basically you should be able to define rules ki when X or when this condition is met. See, यहाँ पे the खेल is all around DB schema design, and how would you design the schema? Building a rule engine that would help you match the correct set of rules and then taking the action. Okay. This problem statement. So if you build this thing, the most common use case of having a trigger system is Swiggy's example. So let's say a driver just completed or just or a rider just basically delivered the food, and now you'd want to do what? You'd want to trigger the system, and once the food is delivered, you have to compute the incentive of the driver of the rider, and then basically add that much of money in his or her account. Right. So these are the rules. So you can take this as an example where the generic problem statement would be to build a trigger framework. A specific problem statement would be to design a rule engine that incentivizes Swiggy's riders. Right.
Yes.
And this has to be extensible enough that you can add and remove rules on the fly. You should be able to customize it, like have some sort of inputs, and then you customize it with respect to, okay, now if the rider has completed this ride in these days, then and B condition and C condition, then basically this is the incentive. Or if other conditions are met, then some other thing is the incentive. Right. So all of these rules. So when I was talking to a few people from Swiggy, they have this rule engine built where they have close to 5,000 rules defined on how a rider is typically incentivized upon a delivery.
Okay.
Right. So you can use this as a concrete example and then try to build a framework around it. But as a generic one, it's all about like when XYZ happened, you do PQR as an action.
Yes. Yes, Arpit. Thanks.
Okay. Yeah. So what we'll do today is information retrieval systems pe yesterday we saw two one is like normal text-based search engine, while the second one was recent searches. Okay. So what we'll do today is we'll be doing ad hoc system design, because like information retrieval may, apart from like going into math and all, recommendations system and all might not be that relevant. But if you'd still want me to cover that, you can just let me know and we can cover it in the next week. Today I was like a little funky. Let's do this. What we'll do is distributed task scheduler, flash sale ka system design. Although a lot of things is already covered, but still let's do it formally. Then computing video view count for YouTube and ClickBus design. Okay, we'll start from the bottom and move to the top. Okay, so ClickBus what we'll do is we'll start with designing ClickBus. So I do not have any slides today, so it will be all discussion. So please participate. Okay.
I just wanted to say one thing. वो जो था ना YouTube view counter, तो जैसे I was just browsing blind today, तो उसमें like there is some view counter of the post. So I just saw like if you open your post multiple times, right, it will not register as a view. But if someone else opens this 10 times, so 10 times views register करेगा.
Yes.
तो
मतलब फिर वो normalize होता है.
हाँ, okay. I'm not very sure. मतलब I noticed this. So there should be something, right? कि even if I open it 10 times, it is not registering it.
Yes. So again, rule engines. So typically क्या होता है? What actually happens is there is always a lot of events are captured at one place, and then although like when I published first YouTube video for some project on a friend's channel, we said कि अरे यहाँ पे view count है ना, let's just keep on opening the page again and again and again, and we made about 5,000 views. So वहाँ पे actually we were seeing 5,000 views, but the next day it turned out it got changed to just 120 views. And that's when we realized that although YouTube immediately at that time was immediately incrementing the count by 1, but eventually there was some system which was being triggered that used to normalize the views, that used to basically mask off the views that were like randomly created, or some false views, or some pseudo views that were generated, right? So then it basically did some legitimized views count, and then it used to update it. So that's what I recalled from that. So ये सब करना पड़ता है for this. ठीक है, चलो. So what we start with ClickBus. Okay. So I told yesterday as well that ClickBus design is very similar to recent searches design. Okay. So let's design ClickBus ka live commentary. Okay. How would you design that? Chalo, let's start. What are the requirements of the system?
It needs to be ordered by time, like and the write traffic is very like burst, like periodically there is a sustained write traffic that needs to be supported.
Sustained write or read?
I mean, write, because the commentary keeps happening every ball or whatever, right? So there will be a constant write rate that will be there, and there will be like 100x, 10x, much times of heavier read traffic.
Let's say 1000x read traffic. Actually, it's much more than 1000x, but still, okay. What else? What are we storing here? We are storing text. Like, so obviously there has to be some limitation to text and all. Right. So what we are storing is text, and it is per ball, bold, per match. Correct. Now what? How will you design this? What kind of database? What kind of decisions would you be making?
It should be append only, right? All the time. DB.
Why can't you update it?
Update why?
Typo हो गया. Now what?
Typo also it won't go further. To I mean, yeah, it can be. Somebody writes. Yeah.
What database would you choose? Why?
DynamoDB, sorry, or a MongoDB, because Cassandra reads are slow because of it design. So maybe DynamoDB or
Why?
It should be some key value store kind of, because we are having just maybe match and the timestamp kind of thing all the time, right?
Think about it. Think about it. थोड़ा सा आगे पीछे सोच लो इस पे क्या हो सकता है. DDB Mongo. Why?
You want a document-based kind of property sometimes if you want to filter by some values. Timestamp is a major key, but if you want other filtrations, like which balls were out or something like some property, having to query by some property in the document would be useful.
Say an event, let's say someone hit a century, you would want to find all the balls in which the batsman hit a boundary, right? You might want to do that, right? Balls, events basically fours or sixes or wicket or retired hurt or something like that, so, right? You would want to do that.
So it can be done even with the SQL also, right?
Yeah, I'm not denying that. You guys are recommending DynamoDB and MongoDB.
I mean, shard maintenance is a difficult task. That's why we are going with DynamoDB or MongoDB, because it automatically takes care of it. That's why we are going with MoSQL.
No, what kind of sharding you will do here? I mean,
like we can sort by match or something like that, right? Like the same thing like you said, because the data can get pretty large over time, right?
Oh yeah, so at time only one chart will be used for this match, right? So you can do with the SQL also.
That if you're shard by match, then your shard will definitely get hot. I mean, let's say a popular match is happening and all the right now
You will not give the read request with the DB, right? You will provide some caching mechanism.
So SQL would be a permanent store and cache would be a pagination store, sort of a. And if the user goes for other, I mean, older comments, then those would be fetched.
Yeah, match over, then it can be archived, right? Maybe after 10 days or something like that. After that, nobody accesses.
Exactly. I mean, who goes and, I mean, it's a very rare event if a user goes for any commentary of an older match.
The same trigger like yesterday, that as soon as the person opens the app, keep the last whatever balls commentary ready in the cache so that it's ready to be viewed.
So again, the question still remains, I mean, SQL or a document deep, right?
We don't really need asset properties, right? What part of most of the data is immutable, consistency, none of these things are very, do we really need asset properties? But the idea of querying by other parts also becomes useful, right? That is the only thing in favor of SQL.
I mean, SQL adds such, if you are like very good at SQL, it's nothing wrong in using it, right? So though you don't know the asset properties, but you have in-house expertise who are good at SQL.
Probably day zero SQL would work for day zero.
Yeah.
Eventually, how we see product growing, we can, I mean.
So even if you see Pinterest, right? Pinterest is a large scale, but they still use MySQL to do everything. So you can have a inbuilt, create your own sorting and logical sorts, and you can scale anytime. That's not a big thing. Before NoSQL came, everybody was doing SQL only, right?
So one thing is clear, right? Ultimately the gets would be called using some caching here, probably Redis, right? For a live match, right?
Yeah, I agree. Yeah, right.
There'll be a replication going on from the main DB, whatever it be it SQL or NoSQL, to Redis, and then a short polling would be happening from Redis every X seconds, right? To get any new commentary, which would be displayed on the front end or an app.
I think it's similar to tag based system, right? Like already we have designed for, and we have used Cassandra for that. So can we use match ID as a tag, and we can store all the comments in a columnar database?
Why a columnar database? Why all of this?
I mean, our queries are based on only match ID, right? We will fetch comments related to.
So that does not justify the usage of columnar database. That justifies usage of partitioning, right? So columnar may, because with columnar database, all the data of a certain column would stay together. So you would use columnar database, as we discussed in the first week. We'll use columnar database when we have hundreds of columns, but we always operate on a few of it and not all of it. Right. So wahan pe columnar. So this columnar database are typically used for analytics purposes.
Yeah, where you need aggregations.
Yes.
Very heavily. Yeah.
Yes. यहाँ पे aggregations नहीं चाहिए. Yeah, we were discussing about communication. I think it was I think it was Vishal who mentioned short pole. Not sure who, but
I think such system generally use long pole. WebSockets became very heavily used for this chat applications and gaming. But here long pole will also be fine, I think.
I disagree because see, the server has limited capacity. It can have maybe a few limited connections concurrently. So short polling is better considering the fact that the request effort is low, and with every new request you just check in the cache and kill it and ask the customer to come back after 10 seconds.
correct. Because with long polling, what would happen is your server would not respond unless it has data. Just imagine match is going on, you hit the refresh is not ending because the server is not sending response and the ball is not bold. So unless and until the next ball is bold, your page would continuously see those loading button, that GIF of loading, right? Because it is waiting for the response. But your server is not sending the response because the ball is not bold. That's what long polling is. It would wait until the data is ready and then it would send back. Right. So long polling, with this, what would happen is you would have, as basically Varun rightly mentioned, that you would have a lot more TCP connections which are open at the same moment in time. And all of them are waiting, because here what would happen is the particular behavior is, let's say there are 1 lakh people watching the live commentary of a certain match, and everyone just waiting for the bold to bold, because what would happen is once someone hits the refresh or opens up that page, the API call is made. It will wait until the ball is bold, the entry is made in the database, and you get the response back. So all 1 lakh connections are simultaneously waiting, which means you would need that big of a machine to concurrently support those number of requests at the same time, right? And all of them would be in waiting state. So you are wasting IO operations, right? So more concurrent requests, more concurrent connections would be there. So that's why short polling is better. Okay, what is another disadvantage of sockets? I think it was Amrish who mentioned that sockets are used more for chat applications. Why cannot we use sockets here?
Sockets,
For everyone.
yeah, it's because it's persistent. We don't need persistent connections, right?
But even if we have, let's say we have, but why would still we not use socket?
Only the thing is you have to scale then. Otherwise, I don't see any problem. You have to maintain.
There is a problem.
Fan out is a bit heavy. I mean, you have to.
But
fan
still,
out
1 lakh
the-
people, 10 lakh people. See, even WhatsApp has to do fan out.
Yeah, other thing, yeah, I
That
got it.
problem is solved.
Because
In your use case, in this
yeah, got
particular
it.
use case.
Because here reader is not sending data, it's a one way, right? So here only server is sending, so don't need WebSocket. So by it's not bidirectional. Yeah. Right. Abhi chamka.
What else apart from this? So concurrent connections are there, but the worst
connection
part would
is
be
also idle for a long period of time because
correct. So similar to long pole, even in WebSockets, what would happen is your connections will just be waiting for the data, right? Because with WebSockets and with long pole, even though there is no bidirectional communication, so even with long pole and WebSockets, your resources are staying idle. Because let's say there is this there is this C8 tire strategic timeout that basically goes for 3 minutes or 4 minutes. For 4 minutes, all the persistent TCP connections are just waiting idle, doing nothing at all, right? So that is a very waste of expensive resources. So idle time is very high. So we typically use sockets when you have where you can say that the idle time would be very low, where the data is updating very frequently. For example, stock market tickers, right? Idle time is very low because the data is constantly getting updated. The data is constantly being communicated over the channel. Given a use case like this, you would go for socket, where you need your users to get a real-time feedback of it, and the data changes very frequently. Then sockets. Otherwise, polling. Okay. Long poll, if your data or if your data is not getting updated too frequently, but you would have to wait until that is done, then long poll. Otherwise, short poll, after every burst of time, let's say every 15 seconds, one request goes in which says ki hua ki nahi hua. Right? These are the critical decisions that we would have to make. Chalo, let's continue the discussion. It has been a great one, by the way, till now.
Yeah, other thing is even this generally people say that if we are using long poll because it's a request response thing, so it has to initiate the connection, then you
Yes.
have this TCP
It
handshake
will be
and all,
waited. Yeah.
right? So, but the thing is here it's not that reader, if even there's a lag of 10 seconds, it's fine, right?
Yeah.
Making connection and
Yes.
getting the
Yeah,
response.
that is
It's
fine.
not completely
Yeah,
real
basically
time.
world is not ending
Yeah.
if match comment is not sent to
Yeah.
the reader immediately.
Yeah, it's not within
Yeah.
milliseconds he is not getting, that's not a problem.
Yes. Yes, Ankur?
But for every request, TCP handshake is just a wastage. Means you are just doing 2-3. Means so that 2-3 TCP.
Is that a
connections.
problem? Is that a problem for you?
It's just a
See,
wastage.
you would be losing something, but you would be gaining something. Okay. If you lose out on those handshake times, because that you anyway do with normal REST endpoints, right? You are anyway expected to do that. Now, if you keep the connections open, that too idle, you may be creating a bidirectional communication but not utilizing it. And for this, which means that you are supporting far too many TCP connections concurrently than required. Right? That's a much poorer choice. It's basically picking from the less evil. So दोनों खराब है, ठीक है? मतलब both are not an ideal use case, but still we can go for short poll because even though the request is fired, the request won't take a long time. So the three-way handshake of TCP is an overhead, but not that big as compared to 5 minutes of idle time over persistent TCP connection. Okay.
And that is just like another use case if we just consider that the Swiggy, कि अभी हमारी delivery कहाँ पे पहुंची. So for that use case,
will you use short poll or sockets there?
So I think socket is better there.
Socket is better there, right? Because when the rider is riding, the data is his or her location is changing very frequently, right? Would you want your request to go? Because if you do this, let's think about how user experience would be. Okay, if you do short poll, once the data moved, request came in. Let's say you are short polling every. See, it also depends on the frequency of short polling. If you are short polling every 2 seconds, उससे अच्छे sockets बना लेते, right? If you are short polling, let's say once every 15 seconds, right? Which means that if you do it with Swiggy ka, when you're tracking the rider, if you're making that short poll request once every 15 seconds, so 15 seconds में suddenly आगे जाएगा. 15 seconds is a big enough time. Okay, so with respect to user experience, would you want to give that experience to the user? Ki suddenly the driver would be at this location and then this, after 50 seconds here, and then 50 seconds here. If you want it to be real time in the communication, because when people have that particular screen open, you can expect that people are constantly looking at it. If people are constantly looking at it, then socket makes sense. But if people are not constantly looking at it, and there is no visible or not very massive visible change in data, right? So socket you use करना, right?
And
Here
and here ball में difference है, मतलब यहाँ पे 1-2
exactly,
second,
right? 1-2 second नहीं 1-2 minute लगते हैं ball डालने को. तो उसके के लिए you are just keeping your TCP connections open, right? Not a good choice.
Match is suspended, right? Let's say suspended.
बारिश हो गई.
बारिश हो गई. Or drink break. So that there's no commentary going on, maybe, right? So something, everybody is hogging the server for
Yeah.
connect.
So बेफालतू में your infrastructure is being overscaled. So अभी अरे अपनी एक विकेट भी चलेगी बताओ 21 for 1 KL Rahul gone. So right now it was raining. So if we would have opened up this thing socket connection, then क्या होता? We would have continued to wait here and we had your TCP connection is created. So many people have their eyes on it. Right? It is basically waste of resources.
उसमें टाइम आउट्स नहीं होता क्या सॉकेट्स में लाइक
होते ना होते timeouts basically it's not timeout based but socket connection might break and then a new socket connection is created because socket connections are persistent. So the socket from the web from the client to your server would be persistent. Our connection is there, right? Unless if it breaks, your client would again try to reestablish the connection.
राइट
Okay. Chalo, let's continue the discussion. We were there with communication. What else?
What about geographical, I mean, distribution? Intercontinental.
Why would you need that?
Maybe quick info. It's not only used in India. Some other country people are reading that. Let's say England and England versus India. So people in London may be reading that in offices and all.
Would it matter if request goes or if your servers are hosted in Mumbai region?
Yeah.
Would it matter if your request flies to Mumbai and then you get a response for a live match commentary?
Yeah, it may be. Yeah, it may be delay of 200 milliseconds, right? Maximum. Intercontinental.
World is not coming to an end because of that.
Yeah, then fine.
Right.
Yeah.
So multi-availability zone, although you might configure, but would be an overkill.
Yeah.
But still you can optimize stuff using CDNs or global cache, some sort of. Okay. Now, how would a data be updated? You know, because yeah, like we were talking about reads. What about writes? When people are writing something, now what would happen? What would be the flow there?
We would first trigger a write onto the Redis cache and then trigger a job to update the backend DB.
Perfect. So may not be a job. You can write it synchronously to both. You can for sure do that. But the first write has to go to the cache because that's what is important. Because your gets are going to cache. So how would our architecture look like? If you see closely, it looks exactly like our recent searches. No alterations whatsoever. So you would have an API server. All the requests would come over here. So you would have two sets of requests. So the first request, first I'll take the blue one. Our first set of requests would be add commentary. So someone who is writing the commentary, right? Now what would happen is you would have two databases. Let's say you have a cache and you have your database, your persistent store. Now when you're doing an add commentary would first update the cache and then update the database for this. Okay. Then the second request would be get commentary. Now this would only go to the cache and get it. Okay. Now this is one flow where it's all about getting the last few balls of it. Right. For example, what do we have in cache? Will we store entire match commentary in cache? Bada.
At least 5 overs. I mean, the page that is there. And if a match is having a very high request of viewers, then we may add a few more caching.
Caching node.
10
So it will be a
hours.
cache cluster. Exactly. Which
Yeah.
is perfectly fine. Your cache will have replicas. From there, it would be able to handle the load. But if you see, this is where the magic of short calling comes in. The request would come in, the request would immediately go to the cache, would get the response and send it back. Go to the response. So it will be a very quick transaction. So get commentary. Now this is all about getting the latest page. So get commentary. This is the latest page. Now there could be another API, which like if you have ever, so if you have used ClickBuzz commentary, you would see that the first page is loaded and then you see load commentary ka button. And once you click that, it loads the historical commentary. And then when you scroll down, it would auto load the previous pages. You can try that thing right now. So this kind of behavior, what it suggests is they have two sets of APIs. I have not checked the network tab, but it seems like there should be two sets of APIs. One that gets the latest page, and second one gets all the commentary in general. And now this is a paginated call
That would be
that
DB.
goes to only database.
Okay.
Right. So this way, what would happen is I get commentary when someone just lands on that page, because that's the basically that's the 80% of the use case where people open up the page, because if they are on the screen, they are already caught up on the historical one and they don't need to keep the previous pages on cache. Now, what would they do is they would have one API that would get the latest commentary from this. Right. So now the get latest commentary would get this most recent page from the cache. Add commentary would first update the cache, update the database, and done and dusted. Then there would be another API that would be get commentary that only gets commentary from the database, which will be the paginated API that would go like second page, third page, fourth page. So I'll just rename this. Oh shit. I'll just rename this to get latest commentary. And this is in general get commentary. So this get commentary irrespective of, because not for all matches you would have entry in cache. Let's say match ended up let's say match ended yesterday and basically today you are opening up that page. What would you do? You would directly invoke get commentary. So if the match is live, then only your client would make a call to get latest commentary. Otherwise your client would make a call to get commentary, which would do normal pagination, scroll and all. But this is very similar to a recent searches architecture. Right. So we are optimizing for reads. So that's why we would not want our reads to go to database for the latest data. For historical data, it is okay if my reads go to my persistent storage. But all of my reads should always go to my latest read should always go to cache. And that's exactly what we have done. And that's why I always say ki recent searches architecture is very similar to ClickBuzz's architecture. And it's all about understanding the building blocks that we have. It's all about Lego blocks.
So how is both consistent, cache and DB, right? Because we are not using two-phase commit here, right?
Hmm.
So generally,
What if one of them fails?
yeah.
So if you're first writing it in the cache, then the only chance is like cache mein pass hua, but DB failed.
Yeah.
Right. So the person who is entering the commentary is not a normal user. He or she has that admin console on which the commentary is added. There you would see that error. Right. And the commentary is always against a ball. So you would save again. So cache mein that same entry will be updated. In DB, since the entry was not created, will be created again.
So it's a two-phase commit.
No. Why two-phase commit? Why you want
Just
to add that complex?
retry.
Just normal read and write.
Okay.
Here, Pet, would it make sense to like use a log-based database like Redis stream?
Which one? Redis?
Streams.
I'm not sure what Redis streams are.
So it is a log-based database. So actually, whenever new commentary comes in, so it gets append only mode.
Achha,
So
append only mode. Why
Yeah.
is that a bad idea? Because typos.
Okay.
Agar
So-
if the person typing the commentary made a typo, and if it's an append only storage, now there is
So
no way for you to to go back and change it, na?
actually we had like a hack kind of, so we can like have an update event on that, so it will get update in the second, so it will like merge those two events and it will like create the updated one.
It will
Commentary.
create the next one. But why?
Yeah.
That is an overkill. Why would you do that? Matlab, if,
Uh,
especially for this ClickBuzz use case, wouldn't
So
that be an
ac-
overkill? Although it seems very tempting to use a
Yeah.
log structured storage, but for any company, this would be an overkill. Like,
It's
why
not
would
write heavy actually. It's not very write heavy, right?
Ah.
So actually it will like for the latest one it will be very, the complexity would be very less.
But
So-
anyway, writing it onto Redis is also very fast. 3 milliseconds done.
Yeah, so we
Do you
can have
really
like,
see?
Yeah.
Let's do capacity planning here. Okay, and see if it makes sense. If it does, we would go for it. Okay. How many concurrent matches would be, or how many matches would be live at a given time at peak hours?
one or two, like,
1 or 2 to international. Na? Let's say domestic bhi kar liya.
okay,
50 matches all
50
over the
matches.
globe. Worst case, huh? 50 matches all over the globe.
Yeah.
50 writes per second. Bhi pakda. Let's say if someone is writing 50 times in 1 second for each match, that would be 50 writes in 1 second.
Mhm.
Right. But in reality, it always happens like 1 write per minute on an average. So it would be like write traffic on your cache would be 50 writes per minute. Would you want to optimize for that by using log structured storage?
And
So
moreover, the commentary on the less famous matches is like one-liner.
Yeah, one liner. Exactly.
4, no run,
Yeah.
just
That could well be automated as well.
yeah, no details.
So
Yeah.
basically, you are saying even let's say DB write fails, he will submit again because it will
It's a
retry.
human user. Like
हाँ.
मतलब normal अपना मतलब basically अपना ही employee पीछे बैठ के type कर रहा है.
Okay. हाँ.
Right. तो वहां पे what user would see or basically the someone who is typing the commentary would see that it failed. So he or she would try to save again. Now the beauty of this is we would always have in Redis it would be like some ball ID, or basically ball ID would be nothing but like match ID underscore inning ID underscore ball ID or something. So like match 172 underscore first inning is 1 underscore 19.6, right? Something like that. That would be the key there. Right? Given that is the key, the commentator who is typing the comment would see that is failed. So in that key against the commentator will again type save, or would again click save, and the record will be saved again. Right, and it will always be a full page replacement. It will always be a full value replacement, which means अगर typo भी होता है, the person can always go back in time, or basically can actually go back and change it. Right, so you would have some ball ID mapping, but you would have some text and some information, maybe some JSON object or something. Right, and this exact thing will be on a database as well, be it MySQL, MongoDB, or anything. In that also you would have match ID and ball ID and whatnot, and in that you would have a text field. So वहाँ पे भी when you will store it, it would be a full text replacement on the primary persistent storage as well. Right, so adding an append only storage, according to me, is an overkill here, because it is not a write heavy system. You might want to use basically going by the explanation which actually Shivam gave, like even if Redis supports append only stuff, you would do it when the writes on the cache are actually very, very frequent. Like it's a very high throughput writes on cache. Then you would have to make cache also as append only. Then it would make sense. But here, if you do like a little bit of back of the envelope calculations, you would find like 50 writes per minute at peak time, which is nothing for this.
Right.
Chalo.
Yeah.
Any other point for the ClickBuzz's design?
So basically, querying will be based on timestamp, right? Last timestamp what he has queried.
Get last page from the cache. So it would typically be for a match ID from cache, give me everything.
Okay. Okay.
right? Because in cache, what you're storing? In cache, you're storing only the the most recent page of that match,
Okay.
right? It would go there. And so, which means that whenever a new entry is created, you would have to delete the old entry from the cache.
Okay.
And that's what you will do here. So it would always fetch everything that it has from the cache, assuming that whenever you are creating a new entry, you are also removing the last entry from the cache. Maybe yet another call to Redis, which would basically delete the entry older than, let's say, 5 overs. If you're having that big of a space key, last 5 over ka maal apan cache mein rakhenge.
But on each request, should not server should not push whole data, right?
Server won't push whole data. It would only, when the write would happen, it would only happen for that one ball.
Yeah. So new request comes, he should get only the new wall data.
As a client, client would get all the data. If
So
you open ClickBus, if you open ESPN Crick Info, you see you would get the entire response.
Oh, is it? So
yeah. And why? Why? Because commentator might have made a typo mistake like 4 or 5 balls earlier. So usko change karke, the last page is always written.
But it would be like bandwidth loss, right? I mean,
बहुत कम data है, hardly 5 KB. 5 KB के data में कुछ नहीं होता. Right? So it's about that. So you, although from engineering perspective, you might think, "Arey, why should I do that?" But just imagine one of the write failed to reach your client. Basically, one of the ball, but now you're only sending the last ball ka data to the client.
Okay.
What would happen? Beach mein ek ball gayab ho gaya na? That's a poor experience to the user.
Yeah.
And even though your cache has all the data, fetching from the cache won't take you more than a few milliseconds. Why would anyone over engineer this problem?
Yeah.
Like as an engineer, we always try to think, let's build the best thing out there. But in most cases, building the best thing out there might not be the best choice.
Yeah, it will create so many corner cases.
Right. Corner cases becomes humongous. Like for example, ball missing. Then to solve this, you would do key. Every client should send me key. I have data till this point.
Yeah.
Now give me data after this. Like API server bolega bhai le le pura data.
Okay.
Right, that would happen, right? That would happen. Yeah, why are you over optimizing for this stuff?
Okay. So there should be like analytics also here, right? Involved.
वो तो अलग system है ना.
Okay.
That would be a different set of APIs there that would store the events and all coming from the back end and front end would be ingested in different places.
So I mean, each match is resulting in some new record or some new strategy.
वो तो अलग से डाले करते हैं. But at the end, typically it's the job of the commentator who specifies what happens, when and why. Like on this ball, this person hit a century, so all of that will be part of the meta information stored here. Okay, chalo. Yeah, anyone else was saying something when Ambrish started speaking?
Hey, Arpit,
Yeah.
I have one more
Please.
argument in favor of log base. So actually, if we use the Redis as the main data store for the commentary, then we can eliminate the cache. Like I was recently reading a blog and they suggested that using Redis as a main data store, so we'll have just a single DB. Which
Why
also
would you
access-
do that? Why would you not have a persistent storage like MySQL or Dynamo or Mongo?
Redis is also kind like in that way. I'm also
What
it is
about
also
if
persistent.
Redis goes down? Or Redis is not persistent; it is volatile.
Actually, we have a failover node, so it is supported in that
But
way.
it's
If we have
possible.
replication,
But then just imagine storing entire history of cricket in your cache. All matches, all commentaries. Would you do that?
so actually Redis has like many configuration in which you have like flash to SSD based ratio. So you can store the new ones in the SSD and the old ones into the disk. So that way you can configure that.
But would you still want to rely on that? If that gets stored there, so you would want to use Redis as a primary storage for this. So then how would you support analytics use case? Let's say we were using MySQL and now we would want to query or do some aggregations on top of it. How would you do it on historical data from Redis? It would have to load that data into memory into structure because at the end Redis is just a key value store. Now let's say I want to find out what's the average number of scores made on this ground.
So that would be like difficult on in that way.
Right. So what you're doing is, although there are tons of configurations possible, by now every single database is trying to be every other database.
Yeah.
Right. But problem that pops up is, the database was always created by basically with an aim to solve a specific problem. So when it tries to venture into category of other database, what typically happens is it solves the other's problem very suboptimally, right? And might be an overkill or over engineering in most cases. Like for example, here, answering the queries might be hypothetical, like who would do that? But if you already have a database like MySQL on which you just have indexes anyway, you can just run this aggregated query. You can just run this aggregation query in a breeze, and just on the fly you can basically gather all the records that were recently broken after this particular highlight happened. Hey, see, I'm not denying. See, you can even do this on graph database if you want. Right? Even build it on graph database, but it's just about making those choices. If you would want to over engineer, you can do that, right? Redis gives us options, but here when you're talking about cache, instead of talking about just any specific database, let's just talk about cache, right? So it's about that. So that other database, you can replace it with Redis, although both of them could be the same instance of Redis if needed, if you'd want to build it that way. But how I would do it is I would choose a traditional database like MySQL, on which I can do runtime aggregations if needed, just by creating the right set of indexes, because not a lot of reads are coming onto the database. It supports good set of pagination. It solves a lot of problem neatly for me. So that would be my primary store. Just because I'm getting that ability to query, to basically fire query on the fly, and that could be very complex aggregations as well. And I would have cache to serve the latest page of my match.
I have a question. Does Mongo support range queries? I mean, as efficiently as MySQL?
Range queries? I'm not sure. Not. I don't think so. MySQL range queries, no. So from this to this.
Yeah, I mean, page
should be fairly straightforward for MongoDB.
Yeah, I mean, I'm just thinking about whether to choose MySQL or Mongo. That's the reason I have asked.
No, should be pretty straightforward for that. Basically, range queries are the most basic set of queries that any database could support. That's the problem we are not using. Okay. Chalo. Let's move to the next part. So videos view count on YouTube. Okay. So this is the problem statement. So यहाँ पे what comes into the picture is distributed computing. So typically, how would YouTube count the views that happens on it? Chalo, let's पहले brainstorm थोड़ा सा, and then we'll jump into this. Okay. So how would you build a system that would count views YouTube? There are 100 million users actively watching YouTube every day. So just imagine the scale, and so many videos are being watched. So how would you design it?
Should it be real time?
Good question. Matlab, what would you do?
I think it should not be real time. Maybe can be real time, but not accurate. Maybe that may be the thing.
Correct. Approximation.
Yeah. You can add the client feedback, just make like if you view it just to give that feedback, but otherwise it should be approximate.
And also like placing it just like Instagram likes into buckets, right? Like a milestone. Like if it crosses a particular milestone, that then that number becomes less, as in accurate. Utna batana nahi padega.
Okay. So basically, accuracy can fall over time.
You mean batching the likes and then updating?
Then after a certain range, maybe.
Okay.
Like after a million count. I mean,
After a million count, 1000 views से फर्क नहीं पड़ता. As simple as that. But by the way, this makes a difference when monetization is on that. So Unacademy ka example, because we pay educators by the amount of watch time they generate for us. So every view, every minute matters. क्योंकि पैसा है.
Then it should be accurate, right?
Yeah. So accurate, it may be eventually accurate. Yeah.
Okay, eventually. Okay, yeah.
and moreover, I mean, I doubt that the client has all the data, accurate data, as to confirm what all views were there. I mean, right? Like if I'm having a channel on YouTube and I want to know exactly what is that the users that has watched the video, right? So they can very well say that the numbers are ultimately normalized. A few of the parameters we have rejected, few of the views, and this is the final count of ours, right? So it's up to YouTube, right? I mean, sort of a mutual trust.
Correct. Exactly. See, there are so many options here. Like you'd have to pick your battles. That's where systems like this make the difference, right? So up till now, in general, whenever you are young or early in your careers, most of the problem statements will be straightforward. But when you go or basically when you climb the ladder, the problem statements become more and more ambiguous, and you would have to take a lot of call on yourself. What should our system be even doing here, right? So the simple problem, like to just break it down to one level, what would be the input to your system? पहले वहां से चालू करते हैं, other things would automatically fall into the place, because that's how I typically approach the problem. I just think about the input and the output of my system. What is the input of the system?
A view API, something like input increment count, something like that.
Okay, so let's say a view API. What would the view API do, and how it would be called?
So whenever maybe a unique identifier of a video is hit or requested for, it registers some view.
Okay.
It will contain the video ID or something like that. What the view
It
is.
would contain video ID, it would contain user, and it would contain video, obviously.
And the time when it was requested.
वो तो सारी चीजें हैं. That is also. Now this is the input. Now comes the part. How would you store it? Let's say someone fired this API. Now what would you do?
As part of the response, I mean, just update in the event and event bus and cache if possible. I mean, in the cache, just update the.
Okay, you added two options. You went like from this end of diameter to another end of diameter. You said cache and event bus both in the same sentence. Batao.
Yeah.
What would you do?
I mean, if it's a popular video, then it makes sense to update. I mean, just update in the event hub because or batch the writes to cache basically.
We should partition the video before submitting to event bus, right? So that you can update in batch mode.
Batch the writes partition to event bus. Okay.
Depending on video ID, so that all goes to one partition, and it's easy to, I mean, aggregate.
Hmm. Nice. Batch writing, obviously. We saw last week ki batch writes the importance when we are building high throughput systems. This is around that. See, everything we have covered. It's not that we are discussing something new. It's just about like just recalling the kind of Lego blocks we chose, like what did we do, how did we do, and just reapplying that knowledge. Okay. So at scale, partitioning will make a difference. Partitioning by video ID, because views of a video ID would all have to be aggregated in one place. So that needs to be there. Writes have to be batched, because just imagine like a Gangnam style video being watched by 1 billion times. Just imagine each API making a write to the database. That would be pathetic. So, Varun, why cache?
It's just for instant gratification. Let's say I refreshed 100 times, it'll update the cache, and if it's I mean, it just shows count is increased instead of putting it in a final store data. I mean, persistent store.
Okay, could be. If you were YouTube 5 years, 6 years back, then you would want to do that. And mostly that's exactly what would have happened back then. Because my view count went to 10,000 and I was so happy after it. Ki chalo, my video would be trending. But that doesn't have a YouTube for. So yeah. So then event bus. Would you put it in event bus, Farah?
Yeah, it is required to dedupe.
Dedupe what?
Dedupe the views. I mean, based on user. Let's say I viewed it 10 times. Then it makes sense to send 10 times with the user ID, so that the consumer can actually dedupe, or it can yeah, I mean, that's what.
Okay, that's a very important thing. That, okay, listen me out here. What would happen? Like, it was yesterday when we were discussing, yesterday, or I think at the start of this session. One person viewing a video 10 times, does it mean one view or 10 views?
It should be one view, right?
Yeah,
Again,
product decision.
after few days, it could be
Based on time granularity, how
No.
spaced across those views are. Like you can collapse like 10-20 seconds of 1 minute. All the views should be just count to one view, something like that.
But it depends on use case, right? Do you mean that video somebody is viewing, whether the likeness of video is more? It's only one individual watching 100 times. How does it matter?
But on YouTube's case, what I was reading that if they have a minimum threshold to register a view, and that will be counted as a view, but watch time and those metrics will be decreased.
Like you don't want abuse. Like somebody can just have a bot and keep loading the view, like the video.
That already happens. You can go and buy YouTube views. There are a lot of services, but YouTube runs a script, or as in runs some services in the backend. Like if you have followed the news that they removed a lot of views from a lot of videos which were very famous. So maybe they do it later at later point of time, but they do register it at that point, as in the current scenario.
But how would you do it? See, at the end, it is our system. Okay. What we should be doing is we should be picking one and then designing it accordingly. Because if we are deduplicating the views, like a person who, like, let's say one of the video is really good and a lot of people are watching that video a lot of times. Right. So would you say, like, through this, what would happen is if this is true, let's say a video got views like 3 billion views. Like there are 7 billion people in the world. Do you say, or would you say that about 50% of the world has watched that video? Is that even possible? Through this, it would also mean that no video will get views more than the number of users that are registered on YouTube. Third case, what about users who are watching YouTube without signing in? Will you not count their views? upset. Right?
Yeah.
So many edge cases, right? So that's why, depending on what we configure our system to be, our platform are going to our platform will actually take the shape according to that. So just adding some spice here.
So what some person just viewed for a second and just closed it will be considered as view.
Typically not. Typically there is a threshold. Let's say for anyone to be claiming that I have watched this video, that video should be watched at least for, let's say, 15 or 20 seconds. Then you'll say that the video was viewed. So at an academy also we do this. We make watch count or the watch time to be at a spaced out of 1 minute. So the person so any viewer has to watch the video at least for 1 minute, and then only we would register it as a view.
So how will you track that video was watched completely? So you should get trigger every regular interval, right?
Yeah, event doesn't from the client.
Yeah.
Like maybe multiple triggers at some checkpoints which might be specified or something of that sort.
Yes, exactly, that happens. Threshold. So typically what happens in this system is we create, because we would also need to measure how, what is the average duration of people watching this video, right? So that is another key metric that needs to be tracked. So what's the average duration that person is spending time on this video? If you go to YouTube's console, the creator console, you'll find those metrics. So typically what happens is every 10 seconds, your client fires the event where it says that, okay, 10 seconds elapsed, user was watching this video. 20 seconds elapsed, user was watching the video. 30 seconds elapsed, user was watching the video. 50 seconds elapsed, user was watching the video. So there are so many repeated events about watch events that goes to the that is fired to the event bus. So through this, people actually compute key what's the average time that people are watching the video, or people are watching a certain video, right? So if people are watching a lot of videos or a video 90% of them, so wo video bahut acha hai, and this needs to be recommended to a lot of people. So that's where watch time is a very important metric. That's why YouTubers employing that cheap tricks ki I'll tell this secret at the end of this video, please आखिरी तक देखिए. वो आखिरी तक देखिए is because that happens because of that, because YouTube monetizes that कि watch time बढ़ेगा, it would come as recommended, people would or plus ads देखी जाएगी, they would get money out of it. This is why they urged and they add this special part at the end of the video to basically entice you to watching that video till the very end. All cheap tricks, but yeah, that's how it works, right? You have to do that. So there are so many constraints or so many decisions to be made here. We'll keep our things simple. The point I would be addressing here is about distributed computing, right? We have already covered part of like partitioning it and then sending it. But now what would happen is every view event, let's say what we do is we keep it simple. If someone watched the video, so this event will be triggered just once. When someone watched the video for 1 minute, this event would be triggered, as simple as that, right? And we would be registering it. No matter if user watched it 100 times, we would register it 100 views count. Okay, but the user has to watch the video for at least 1 minute. And then this is all handled on JavaScript side, right? We don't have to worry about it. It's all handled on the JavaScript side. So from the front end, we'll get like, okay, user has spent 1 minute on this video. Let me trigger this API call. This API call would come to the backend server and it would be registered as a view there. Okay, simple. Chalo. Now, how would our architecture look like? So what we have is we have a यही तो हो गया ना diagram अपना, इसी को उठा लेता हूँ.
And like for this analytics, from what I see, like I was just working thoda sa on my current project. So a lot of things are integrated with a lot of third-party vendors, which make this possible analytics. Yeah, as in just a company grows or your team grows, they'll try to build it in-house, but there are a lot of tools which kind of leverage this using the front end part. Like they'll like inject JavaScript and all, and that will make the
Yes.
API calls and store the data in the backend. So
Yes.
some which we are using are Intercom, WalkMe, and Full
Yeah.
Story.
वो तो लगता है एनालिटिक्स के सारी चीजों के लिए and it gives you great analytics. It gives you heat map of your website कि on what part of your page user are spending a lot of time. मतलब heat map भी आता है.
Because like my marketing team में हो ना, तो ये like there was one also called Hotjar. So
Yeah, Hotjar.
And you can trigger various functions like I'm not very sure, ये मैंने बाद में notice किया, like if you hover your like website अगर कोई है, and if they make a trigger that user hovers to a next tab या फिर cross button पे, it will immediately pop up with a feedback bar. Like कभी कभार feedback bar वाला pop up आता है ना, like leaving the website.
Yeah, no.
So those are like only triggered when you do certain action.
Crazy. World is like basically privacy is a myth. They track everything. क्या कर मजबूरी है. ठीक है. So what do we have is we have this event bus on which we do this. So our /video/view count ka API, once it gets triggered, it would basically publish the message in the event bus and it would return, right? And it would immediately acknowledge that I've got the request. That's it. That's all it does. Okay. If you have used mix panel or if you used intercom, uspe open the network tab of it, you'll see that a lot of APIs, when they are hit, the only response they get is like normal okay. That's it. Basically, that's all it returns. It's basically an acknowledgement that I have saved this thing. So if you use mix panel or if you use amplitude or any such analytics tool, you'd find this. So this is typically a high throughput incoming things where a lot of events are constantly being fired onto your API servers. So API servers simply acknowledges it, says okay, I have saved it. But what it does is it just stores it in Kafka or any sort of event bus, maybe Kafka Kinesis, pick one that you like. It would store that thing. It would partition it by the entity ID. So YouTube, in the YouTube's case, it would be partitioned by video ID. So what would be the, the reason why it needs to be partitioned? Because aggregation of views cannot be like how would you batch write it? So at scale, this becomes a really tough problem. So let's say you have your database which stores the count system. You would have consumers running whose job would be to do what? To read everything that is coming in, batch it for some time, right? Basically aggregate in memory for some time and then write it to this database. Correct? Right? अब वो कैसे करेंगे? Right? So that's where tools come into the picture that gives us this thing, but it is also very simple to do it, not a big problem. So typically video views on YouTube, like let's say ABCD are video IDs, what you get is stream of input like this, like so A B A C A B D C B D something, so along with some meta information like who watched it and all, right? So these are millions of views coming in every minute. To compute the video views in real time, it is not possible to be done by single machine. So that's why you would have to partition the things, right? And you would not have enough RAM to hold this dictionary, like this event, this count happened and all. So what do? We do it in we do it in a distributed manner. So let's say we have 4 video IDs, A, B, C, D, and this is what we got as an input stream. Let's say my consumer pulled the data out, and what it got is this. So what are these consumers? This, you can think of this as like my Kafka partitions. Each consumer points to one partition. My video is partitioned by video IDs. There might be thousands of videos, but all of them that maps to a certain partition will flow here. Now my machine 1 would read all the events in a 5-minute batch from Kafka. It would continuously read those events, and in that it would try to hold up it. So video ID and count, video ID and count. It would basically it would continuously try to keep it in the in-memory hash table. Similarly, for second machine, third machine, and fourth machine, it would do the count, and then it would in basically batch write it in DB. It would do in database count plus equal to X. Right. And this is how distributed computation typically scales. So partitioning in-memory computation, this is how systems that require in-memory computation, aggregation, batch writes, this is how these sort of systems are scaled. Okay, seems like a very simple solution, but a tough one to implement, to be honest.
This is exactly what we have implemented in my earlier company. So it was an advertising company, so we counted impressions.
EdTech is thriving because of this architecture. Sorry, systems are built like this. Every single system is built like this.
Every component we had was connected with Kafka. It was all async.
It's all async, like basically event-driven system. Everything is an event.
At the end, we use Hive to calculate and then store it in V, and then give it to analytics team about for billing and all.
Exactly. So now, although the example that we took was just about YouTube views, now basically as Bhupendra rightly mentioned, EdTech world all around this event-driven system. Think about AWS billing system. Like how would you build billing for AWS? Like your EC2 instances are running and you are being billed for every minute of its use. Right? Wahan pe, all of these are events that are being fired continuously. Right? And then at some point they're aggregated and the billing is structured. So that's another great system to build in. So EdTech systems, billing systems, any systems that requires aggregations, sab yahan se aata hai. So you would find this to be very prevalent across so many systems that require distributed computing and aggregation. Right. So if you ever get a chance to work at company like InMobi or any EdTech, this is what like your day zero would be. Like you would have to know event-driven architecture, in-memory aggregation using Spark, Splunk, या कोई तो भी ऐसी चीज, and you would be building this. अच्छा, by the way, I wanted to cover that Spark and Splunk वाला thing ना, वो करता हूँ cover में. Ad hoc में वो रहेगा. Maybe next week में I'll cover that. Yeah.
So here we can scale partitions differently. We can add like some partitions become.
You can add more partitions to Kafka, and then depending on the number of partitions that you have, you will have those number of consumers or those number of machines running in.
Okay.
Let's say here we created 4 partitions. We had 4 video IDs. We created 4 partitions, but instead of 4, there could be 4,000. So each partition will randomly handle 100 videos. All the views of those videos would come there. This way, if you're even making an in-memory dictionary that would batch all the events for that video for 5 minutes, it would be there. Like basically, if in one machine, you cannot have this big of a dictionary that stores video IDs and counts. So that's where you have to split it horizontally. And that's where you are partitioning it by video ID. And now, यहाँ पे partition है, so how are you accepting data in partitions? So through Kafka. So Kafka data partition, split across multiple machines, batched in memory, count aggregated in memory, and this delta is then being done here. So count plus equal to X in the database. So her write pay, you are not making a write to the database because the database would go bad. That's why you're just batching the writes and then doing a count plus equal to X. Right. If you see jahan pe bhi we had write high through we had a high write systems, we always did batches. Like there is no magic sauce to solve this such problems. It's all batching and caching and stuff. Okay. And now to do this, there are frameworks. There are frameworks like Spark, Splunk. Read about Apache Pioneer. Just read about it. बहुत मजा आएगा. मतलब just so that. So MapReduce is the old guy in the room now. But Spark and Splunk have actually taken its place because it's all event-driven stuff. A lot of companies are using this. There is a company called Monte Carlo. This company is doing amazingly well in this space. Then there is another company called Segment that actually does not give this solution, but yeah, you should know about the kind of scale that they're operating on. So Monte Carlo gives data engineering as a service. It's a B2B company that gives data engineering as a service. So they have a cloud formation template and they spin it up on your infra, and you have data engineering on day zero itself. right? It's that simple to use.
So,
So
something like Snowflake, right? Snowflake also does the same thing, I guess.
Snowflake company ना, हाँ वो भी वही करते, correct, वो भी वही करते. So Monte Carlo, Snowflake, all of these companies do that exact same thing. And Databricks ने Spark का लेके रखा है, right? So Databricks be on the similar lines. Yeah, so just keep in mind we have like so many options to go, but do explore MapReduce, Spark, Splunk, Pino. Spark Splunk का basic I'll cover in next week. आज मस्त mood में अपन तो questions cover करते, but I'll cover the basic of Spark and Splunk next week के first इसमें. ठीक है, थोड़ा इधर उधर spill over हो गया but चल. एक मिनट, chat में कुछ मैसेज है. Yeah, Varun, you can do that. No problem. Okay. Let's take a quick break. It's 5:15, 5:20 तक break लेते हैं, and बाद में क्या है? Flash sale and distributed task scheduler. Right? Again, similar pattern बस discuss करेंगे and we'll build system. Okay. चलो. Thanks guys. 5:20 को मिलते हैं वापस. अरे वरुण, feel free to post the message on Discord channel ना, चलता है बोलते. अरे दूसरा भी गया, रोहित शर्मा is also out. तो जीती भी ना इसका. ठीक है. What I would want to do is, shameless plug. यार please rating दे दो. I'll share the links in the comments. Rating and NPS testimonial. So please, rating. And if you like find it really helpful, then a testimonial would do wonders for me. So do rate the course. कैसा लगा? How likely are you? Just one question. बड़ा नहीं है, just one question. How likely are you to recommend the course to your peers? And second one is more about testimonial. If you like, thanks for time. Please fill this out. मैं basically 7th or 8th week में थोड़ा सा push करूँगा. So yesterday, today, and next week में ताकि यार rating मिल जाए. चलो. Oh, sorry, I just sent it to Varun, I guess. Sorry, yeah. 1 minute. Posting it again to everyone in the meeting. I got 2 links. Yeah, 2 links. First is for NPS. Second one is more for testimonial. Thanks. Okay, chalo. Let's come to the more exciting part of this. Flash sale. Xiaomi. Like when you hear the word flash sale, the first thing that comes to your mind is Xiaomi, isn't it? Adana? ठीक है. So Xiaomi, let's design flash sale for that. How would you design flash sale? So let's brainstorm.
So we need to have a consistent counter.
Why?
To keep the count of units.
Why?
So flash sale means what? Here there are two categories of things people talk, right? One is the way of like how this thing Shopify, that is like multi-tenant way, and they allow only first 100 or whatever quantity, only that much. So they reduce
That's exactly what flash sale is.
that. But like Amazon or Flipkart sale, it's not first come first serve, right? Whoever succeeds, kind of.
Yeah, but
So
that's also first come first serve, right? Matlab, whoever succeeds, matlab, they have a fixed inventory.
yeah, so I was watching some video of Shopify architecture. They use some queuing mechanism to do that. I mean,
पहले answer solution पे बात करते हैं. पहले समझ तो लेते हैं. Yeah, we want consistent counter because we have fixed inventory.
Yeah.
Okay. Now what would happen when we have fixed inventory? During flash sale, you would typically expect like surge of traffic, right? Up चालू करते हैं इस पे से. What would happen? How would you do it? How will you manage fixed inventory? How would you create those counters and all?
So we should have a limit in the UI as well. 10-second counter. If it expires, add it into the. So let's just say when I click on add to cart, the inventory should be subtracted from the consistent counter. And I would have like 10 seconds or something. If I order into that time, then it's good. If I don't order,
10 seconds is pretty less. Should be at least 10 minutes.
And for something like Xiaomi, like उसमें 10 minutes में sale खत्म हो जाता है.
No, but then in 10 minutes you would have to make the payment. Nah? You're given that much of time to make the payment. Even 2 minutes ka time at least.
हाँ मतलब.
So 1 minute. Let's take a step back. What's the flow here? So people would see the item.
Yeah.
Then they would click to basically not click to, but they would add to cart.
Checkout.
And then checkout. So checkout पे आ जाएगा basically payment का flow. right? यहाँ पे we have two scenarios, your payment success or failure.
So one question is, when would we deduct the quantity from the inventory? मतलब add to cart के बाद या payment success के बाद?
You tell me.
I think it's
So it should be like
Payment
a,
success के बाद होना
time,
चाहिए.
right? After payment, if the inventory is there, then you should be errored out. Before payment, inventory check should happen, and before that, see the item add to cart all should be allowed. I think.
I think checkout तक allow, checkout page that we can allow.
When count minus. So basically once I initiated the payment, that's when I would remove the count, is it?
No. Payment is done, then only.
It should be after success, I guess.
Yeah.
क्योंकि लोग मतलब people might abuse it. They can hold the payment for a while. Success के बाद even if you deduct, we can refund it. Like if but I'm not sure if that is a very good user experience.
Would you buy from a website that does that?
नहीं.
You have the answer. You
No.
have the answer. But
Before payment, he checks to inventory whether they have or not. Before payment done, before payment initiation, right?
But
So,
what if by the time someone else completes its payment and we have the last quantity?
no, so yeah, then count should be decremented as the payment goes initiated, right?
Yeah,
so slow. Everyone please think.
I think a good product is that you try to alert the user if something is fast moving. So you can have different behaviors in both cases. Like Amazon shows 3 items left, something like that. So for that, the behavior that is
So
in high
that would
demand.
be here. 3 items left.
Yeah. So for that, if something is in high demand, then it's like you can use a different behavior, like at that payment success, first payment success.
Why would you want to have two separate things? Why? That's typically a bad system where you have 2 gigantic flows for the same thing to happen.
So when we add to cart, right, it will be a lock, and that lock would be held for X time, 5-10 minutes to the payment. If the user is not able to do the payment, and then the item would be unlocked and back to the flash sale.
Perfect. So now when would you do count minus?
Yeah, when we add to cart.
When we add to cart, right? This is very important. You would do a count minus when you add to cart. Why? Because if let's say there are 50 people who see when something is added to cart, and then obviously you would have to have that check key, because after adding to the cart, people are going to click on the pay wala button. Once the pay wala button is, then the payment wala initiate happens. So when payment is initiated, which means the control is moved out of your website into the payment gateway's flow. Correct? Because this process can take easily 5 minutes to complete. Right? Because like I'm waiting for OTP. Nahi hua na, aaya nahi na OTP. Right? So this is what the variable part is. So initiation of the payment and then picking up the card, filling out the details, all of these are they are all time consuming steps. Right? You always need to be wary of the fact that which part of your system or which part of your process is variable and which part of the process is something that you can predict. The things under your control are predictable to you because you'll have strict SLAs. The things that are not under your control are variable to you because you cannot guarantee what's going to happen in that. Okay? So typically doing a count minus, your user should immediately see that this is gone. Right? You should not even allow the user to add to the cart. Once the item is added to the cart, why this? Because if let's say 1 million people are trying to buy 1000 inventory, right? So 1000 inventory, 1 million people are trying to buy it. And if you add it to million people's cart, what would happen? And then, because then you would again be doing check who made the payment and success pay, wo pura transaction ends and all. So you would be giving a false hope to a lot of users. You should always try to minimize giving a false hope to a lot of users. So count minus minus kar do. If the payment fails, you can always plus the count. Okay? Yeah, Anshul?
I think there will be one more state, like adding to cart ke baad, there should be one more state where the before the payment initiation, basically at the time of clicking, choosing the payment option.
वो पूरा
Which
initiate
payment
payment
option?
में आ गया ना, पूरा payment में आ गया ना. Let's say you just have one button which says pay now, and pay now पे जाके you are basically picking the card and all of those stuff.
So basically, when you add to cart, it can stay for long time period of time.
Yeah.
There. So if I add a particular item and I can add another item as well after that. So I think that will be at the time of checkout. When I check out, and at that time there will be an API which will check whether this item is in stock
Still
or not.
available or not.
Then after that we will apply a lock for 5 minutes.
So that is something that you can do, because typically that would not happen in flash sale. In flash sale, you would try to buy that just one item. You will not go ahead and add another item, right? Because that's what flash sales are. You are just meant to like basically quickly buy that one product. That's a normal user behavior for that, right? So, matlab, what you are actually trying to do here is you are trying to address a generic e-commerce use case.
Yeah.
But for a flash sale, this user behavior might not be true. Okay.
Got it.
So obviously, this is not the only way to design a system. We are just discussing one of the ways to design a system. You can pick it at any other place, but what's definitely the wrong place is something that we would basically come to a conclusion कि कहाँ पे count कम करना चाहिए. मतलब if you're not doing a count minus, or if you're waiting it till very end, then that would create a problem, because then a lot of people, like, you should never be doing a count minus after you get a success or fail. Why?
Yeah.
Because paisa le liya aur maal nahi hai, to ye galat hai na.
You have to refund to so many users.
Refund kahan se karenge?
What about so many people start adding cart and don't go till payment stage, right?
Have you used Book My Show?
Yeah, Book My Show I have used.
क्या करता है Book My Show?
Book My Show. वो तो लास्ट में बोलते हैं नहीं है, right?
नहीं. Book My Show, when you
they lock the seats.
It locks the seat. It locks the seats for some time, and it's typically 10 minutes. So it suggests that you make the payment in 10 minutes. Otherwise, the seats that are locked will be again made available.
So here we are not inventory,
you
right?
have to do exactly that. You have to do exactly that, right?
Okay.
Because if we don't do this, so the first milestone for any user would be when I add something to the cart. If I'm successfully being able to add to the cart, which means that when I click, the inventory was available and I got a lock on it. Once I got a lock on it, now what would happen? I got a lock on it. I'll start making the payment. So I have some window. Let's say 5 minutes I have to make the payment. If in 5 minutes I don't make the payment, I would be losing out on this deal. But if I'm able to make the payment and complete the transaction, then the item is mine. So till the time the item is in your cart, you have complete ownership on it. If you make the payment, the item is yours. Otherwise, koi aur leke bhag jayega. Right? So item will be made re-available after you were unable to make payment in 5 minutes.
Okay. So here it's just count matters, right? So it will be some constant check. That's all.
Yeah, count matters, right? Because agar hai nahi, so the first few flash sales of Xiaomi, if you waited for 10 minutes, there were higher chances of you getting a phone. By the way, I did that and got my first phone. Right. So Xiaomi's flash sale was there. Which one are MI4, MI5 something? And what happened was everyone was trying at 12. It was 12 p.m. flash sale. I went in at 12:05 and I got the phone. All of my peers were trying for 12 and they didn't get the phone. I went on 12:05 because that 5 minute was the duration, that lock time. And this was there in the API. So the first API that the loads on the page, usme they send a parameter called timeout. And the timeout is set to 5 minutes. And this 5 minutes is something that the site was waiting. They used to show this timer, but then they stopped showing it. But it was still there in the API. So through that, I waited at 12 and then I went to the 12:05 ka time and I got the phone. Very simple strategy. And it works. It works in most flash sales out there. Like, because this is typically how the system would be defined. Because once you have added to the cart, it should not happen, because this is a much poor experience to the user. If you are adding it to the cart, allowing the payment to happen, and then saying your item not available, right? So count minus minus pehli kar do. Do not even let people add already already drained off inventory. अगर खत्म हो गया, if there is no inventory left, do not even let people add to the cart, right? So this is something like, at the source itself, basically cut out the problem. आगे तक आने मत दो उसको. So basically filter out the junk at the first part. And then if there are people, let's say inventory was of 1000, and if people are unable to make payment, let's say few people are unable to make the payment, right? Let's say 3 sessions, like say me, my wife, and one of my friends were trying to buy one mobile phone for me, and we 3 were there, right? We all 3 are trying to do it at the same time, right? So, and for all of us 3 may the item got added in the cart. So kya hoga? Ek ki payment will be complete and other 2 will just basically shut down their browsers. Correct? Now when this would happen, those 2 items which were added into the cart after 5 minutes will be made re-available to the users.
So how does it I mean this case, right? So they will be holding some rollback mechanism, right?
वो बनाना पड़ेगा सर, अभी implement करते हैं ना वो.
Okay.
Right. चलो. So count plus plus should be done at a very initial. So just before adding to the cart. So according to me, if I would have designed a system, I would have done count minus minus over here. Like just filter out the junk before it even enters your system. Right. So see the item. If you don't see the count, ये कुछ नहीं होगा. If you are able to add it, this has to be an atomic update, and then only you would be allowed to go to this place. Clear, everyone?
Yeah, right. Okay.
Now what? What's next?
So basically, we will not be updating because throughput will be very high, right? So can't do the DB update this case, right?
Redis seems like a very good option to do this. After we add to cart, decrease the count, and when it's 0, like once it's 0, disable it. And when someone tries to add to cart, even after it's like if the UI is loaded and when they try to click on add to cart, we can show an error message that the item is not present.
So where would you store this count?
I think Redis would be a good option. Yeah.
But which property of Redis are you using here?
So atomic increment something, right?
The retention period thing.
No, it's only just doing a count minus minus till this stage. We are not doing anything else here. We are just doing a count minus minus. So why can't we use any other thing? Why only Redis?
It's in memory, right? Otherwise,
what if Redis goes down?
Redis goes down. Okay. There should be some replica based, right? Replication.
Down होगा, सब फट गया, सब फट गया.
Serializable
AOF kind of mechanism, disk, right?
Just give me a minute of it. Yeah, Varun?
Man, see, even Redis, you have the serializable persistent configuration. Right?
But still, your node crashed. Basically, there was a mice who basically ate the cable.
The cluster, Redis cluster, instead of using a single Redis.
So just kill the mice.
Persistent MySQL storing like after the order is placed. So even if everything goes down, we know how many orders were placed.
Exactly. So what should we do is, if you would have seen along, basically throughout this course, what I've actually tried to do is try to ping you guys about not the tool that matters, the property that we're using matters a lot, right? So what we definitely want to do is, no matter how many people try to come in, the count minus minus has to be done atomically, right? If here we chose Redis out of the box just because in memory and all, but what actually matters the most here is we leveraging the property of atomicity, right? We need atomicity. So any database that would give you atomicity would do the job. No one is saying no to Redis, right? I would have exaggerated the things where your Redis cluster is going down and all, but it is very important to understand that if your things are persistent, because a lot of persistent key value stores gives you very high write throughput with atomicity guaranteed. For example, DynamoDB. So even if that goes down, whenever it would boot up, it would still hold that information together, right? But if Redis goes down, if it comes back, and let's say if it's a very vague or if it's a very naive config where it is volatile and not being and basically not being persistent enough, then you might lose out on data. And I know, Shivam, there are configurations on Redis, not saying no to that, but what I really want to emphasize is like understand the which property are we exploiting, right? So that's why I always say that basically there is no one way to design any system. It's all about playing around the properties that we have. So any database that would give you atomic decrement of values would do a job for you, right? Not just decrement, but maybe if you want to store some values atomically, let's say who holds this item. Like for example, there is this device ID against which you would have to store who owns this thing, like something like a lock, right? Because eventually in the system you will be acquiring a lock on that, because once you've done count minus minus, did an add to cart, and then when you're going to make the payment, on that add to cart you are actually taking a lock. Although we were discussing about just doing a count minus minus, our main actually intention would be for that item, we're taking who owns the lock on this, or which user ID actually owns the lock on this, right? So that has to be an atomic operation, right? So when so the core property that we would want to use is atomicity. Any database that would give atomicity is something that we could use. So it could be Redis, it could be DynamoDB, it could be MySQL, it could be Postgres, whatever, but it should give high write throughput पे atomicity guarantee. That's it. Okay. And if persistent, the better.
So MySQL would be able to handle that load.
आराम से.
How many? 10,000?
कितने आएंगे? आप ही बताओ. Let's do capacity planning. How many requests would come in? 1 million people trying to buy that phone. That's nothing if you are having fixed set of inventory, because other connections will just wait, right? But the first few ones would go in. Right. So the people who would get the count will be, or the first few transactions would go in and they would acquire the lock on that object. That is perfectly fine.
So if millions of users are there, and so MySQL at any time maximum, I'm not sure, 10,000 maximum can be, right?
नहीं बढ़ सकता है, आराम से बढ़ सकता है with ease. Okay. But understand the use case. This is just the use case of this splash sale, right? What we seek is atomicity. Okay. Chal, let's yeah, Anshul.
So
just give me a minute, Amrish. Others have questions. Let me cover them. Yeah, Anshul.
Will we have lock on item ID for this API?
वो लेना पड़ेगा ना. We have to take lock, right? Because then only we would know who owns this item right now. Like just imagine Book My Show. Who owns these seats for now? I would have to take that lock.
No, I am talking about the add to cart API. In that, if 1,000 users want to add a particular item to the cart, so we will need a lock on item ID. Like at a particular time, we will decrement only one item from the count. Otherwise, the items might go in negative as well.
Yes, exactly. So lock वही तो लेगा. तो basically that's exactly what atomicity is doing there, ना? It will atomically decrease the count. Right? Okay. Now that we have reached this stage, okay. Now just imagine, okay, what this is basically, or rather what real time or what real world situation is this mimicking? Like this count minus minus. They are basically allowing, let's say, 1 million people trying to do something and allowing only 1,000 of them. What real world thing is this mimicking?
IRCTC.
Vaccine
Not real
finder.
world. That is still
Vaccine
software.
slot
That is
finder.
still software. What real world thing is it mimicking?
Real world.
हाँ, इंसानों वाली दुनिया, अपनी वाली, जैसे बच्चों वाली दुनिया, बताओ.
Ticket booking.
Ticket booking, actual physical ticket booking, right? Now just imagine when you were a kid, you went to a park. Let's say thousands of people are waiting to enter into the park. There is someone who is sitting at the counter having physical tickets. Person gives out money and gets the ticket, and then that person is allowed to enter, right? Now what we have done here is we have done atomicity by doing counter and blocks, right? What other thing can be done over here? Like, can we not, right? So all we are looking through this system is what we need is some sort of ticketing system, someone having like physically those tickets and handing it out to them, right? So what if hear me out, what if I create, let's say my inventory is of 1,000, let's say my inventory is of 1,000 inventory, and I add 1,000 messages, I add 1,000 messages in my SQS queue. Okay, and whenever someone is trying to select this thing, what my API code would do is, since my SQS gives atomic reads exactly once delivery, what if I just try to pull the data out of my SQS queue? Whoever gets the message can proceed. Otherwise, people are waiting for that. Correct? What if we do this? Because this is also very similar to what we are actually doing with this counter. Right here, physically, it's like basically your application code getting that ticket from the SQS, because SQS gives you atomicity, right? So that's where the core property of atomicity actually kicks in. That's why we are seeking atomicity so much, because this is where atomicity comes in. Like, only out of, let's say there are 1 million people who are simultaneously on the system, they all make a request through your API server. Your API server will ping, all of them will ping SQS, but only 1,000 will succeed, because there are only 1,000 messages. Other calls would say that no messages available, and they would not get any response. So then they would say that out of inventory as a response to that. But the ones who got the message would say, okay, now the item is added to the cart. Right.
You will be using this queue as a throttler.
Yes.
Okay.
Right. So this is an example on how we are leveraging the core property that we need from not just a traditional database, from a seemingly unrelated system like an SQS queue. And we can build system however we want, right? So there is no one right answer, but it's more about understanding we can use all of this stuff. And the inspiration for this has come from where? It has come from the real world scene where actual ticket booking happens, right? So these messages, so someone has to pre-populate. Let's say I've created an inventory of 1,000. Someone would have to pre-populate 1,000 messages in SQS. That's a different problem. But again, just 1,000 messages. Someone would have to insert 1,000 messages into the queue and keep it ready. And then everyone would just try to get those 1,000 messages out one at a time. The one who gets it has the lock on that. Right? Yeah, Umang?
Shouldn't it be like
wait. Amrish, Umang wants to say.
Yeah.
Umang?
Yeah, so like HFT systems also work on something similar, like if SQS is not there, like, as in I just wanted to know, like SQS, so I'm not very sure when the Amazon released it, but if SQS was not there as a service, what actually would have implemented it? Because this seems similar to HFT, right? At the end of the day. And that's why all the trading firms have build their data centers nearest to the actual physical location where the trades get executed. So
SQS thing hota, they would have used a normal database. See, I'm not saying no to a normal database. It's just about there are other ways to also implement this same thing.
yeah, obviously.
So,
Yeah.
so we are just using the atomic property of a message broker and the exactly once delivery of it, right? So message broker guarantees exactly once delivery. So we are just leveraging that and using it as a locking system, right? So just basically different ways of implementing the same thing. So once someone acquires a lock, then it's a different ballgame. Now that I've acquired a lock, so I can acquire a lock through this system or through this system, depending on however I'd want to build it. Okay. Yeah, Amrish?
What I was saying, instead of like you are telling me pre-populate the queue, if we know that this is the inventory count, we can just keep, as we are anyway decrementing it, we know that when is it's going to be 0, right? After that we stop.
But it's not just about count. Now extend this thing to other meta information. For example, let's say you have device ARNs also, who owns which device to that level. For example, doing a flash sale of movie tickets, you would have seat numbers associated with it.
And
you would get so you need to have that, pinpointed spot that I have acquired lock on these 2 spots.
In that case, I agree. If there's item is associated, then it's okay.
Yeah, exactly.
But if it's a count, just then
it's again. So obviously, it's not just about just basically sticking to this system. So along all the discussions that we had, we never stick ourselves to just that system. We always like expand it. Kaise ye bhi ho sakta hai, wo bhi ho sakta hai. Like basically, that's what we have to understand. Kaise kar sakte.
Another question. So you
Amrish, attend ना थोड़ा सा. बहुत कुछ cover करना है अभी.
Okay.
ठीक है. Now what we'll do is, now that we have the lock of it, now that we know that our item is added to the cart, now our timer kicks in, right? Now what we'll have a timer. We'll have a timer, let's say, of 10 minutes. So within 10 minutes, someone would have to make the payment, right? Agar 10 minutes to payment nahi kiya, then it has to be released, so other can make the purchase. How would we implement this? Hello? Locking.
So yeah, it would be Redis, that thing, TTL thing kind of event, right?
But then how would you know that your thing is expired?
So when he is initiated, when he got into the queue, right? So Redis will have an entry, and if it expires, then there can be callback, and we'll do that.
Expiration पे callback नहीं होता.
Expiration is Redis has this thing, right? On expiry, TTL expiry, there's a way you can register the callback.
Is it?
Yeah.
I've never used it. Yeah, Anshul?
We can have a cron job or something like that. Not a cron job, sorry, quads, where we can set a time for a user, and this is the item ID, and run this process for adding it back to SQS or something like that.
Correct. So there are multiple ways to do it. Again, if you see the fan outs, now things are not just like very straightforward one answer spot, right? We are just leveraging on the features. So what we can also use DAGs, something like an airflow. So every single thing of this could be a workflow of its own. If the payment does not happen in 10 minutes, do this. If the payment happens, do this. This could also be done through an event-driven architecture, right? So there are thousands of not thousands, but basically there are hundreds of ways to implement this. But the most common way to implement this is just take a remote lock on the seats or on the tickets or on the item, right? So let's say if we were designing Book My Show, our lock would say that this seat is taken by this user ID. If it was a flash sale, it would say that item 1 is taken by this user ID. So you would have key as the unique identification of that item, and the value would be the user ID who right now has the lock to it, right? And now this lock you would have a TTL of, let's say, 10 minutes. Now what would happen is, within this 10 minutes, you would have to complete the payment and get the transactions done, right? And this 10 minutes is good enough time for anyone to make the payment. Now what would happen is, after this 10 minutes, I was not sure if we can do this via this basically if Redis gives us callbacks or not. I've never personally used it, so I've used DAG, yeah, Airflow to mimic this sort of workflow. This is what I've very heavily used. And for Redis, if it is not there, I just do a repeat check post the payment. That once I've received the payment, I'll do something. Okay. So here, once I've taken a lock on this, this would also alter the state of the seat, which would mark it as like something like logged. Maybe you have things like logged, available, and unavailable, or something like that, like these 3-4 states on it, and you will be updating it there. Right. So that is that. So here you have 10 minutes to make the payment. If you make the payment and if the payment is successful, then the entry would be removed from the cache and you would update the database. Okay, now the order is created for this user. If the payment failed, you would anyway get this thing. This failed. Payment failed, so you would basically make it available again. Because to make it available, all you have to do is just remove this thing from the lock and update the count to count plus plus. Right. And then the third part, if user did not make the payment and let it expire. So if Redis gives you callback, then do that. Otherwise, I typically did it with Airflow and a cron job. So that works well because it's a flash sale, and not even a cron job, but a continuously running process would also do the job. Like immediately by doing an iteration on it to find out if it is expired or not. If it is expired, then I would have a check. Okay, these are all expired and this is what I got from it. It's a very hacky solution, but it works well. Okay. Yeah, Anshul, you have something to add? Or was it
No,
from the last
nothing.
time?
Sorry.
Okay. Yeah, Amresh.
So how will you do with the Airflow? Let's say TTL gets expired, right?
It's the workflow, no? So the timer will be managed by Airflow, and once it hits off, it basically triggers that job.
Oh, so it how will Airflow know that it?
थोड़ा internal देख लो.
Oh,
है एक बार implement करोगे, once you build it, you'll see all of those things are already implemented. We don't have to worry about it. Okay. So the first implementation which I did was actually using a cron job. When we were building flash sale for courses at Unacademy, we did it with cron job. We supported about with it 50,000 user trying to simultaneously buy a certain course. This is what the peak that we saw. It was in production just for 2 months and all. Right. So that's where remote locking comes into the picture. We took a remote lock. We waited for that time. There was another way through which people did it, which I found that people created threads which waited for 10 minutes, which was very sad to see that implementation. But taking a remote lock on Redis and then basically having a cron job that checks if this key expired or not. So we used to have like for each item. So for each flash sale, we used to have just one Redis DB dedicated to it. We used to do a key star, and we used to get all the keys that are there in that particular Redis database and see which all items are booked. And we used to have this master database having all the item IDs, or basically we were basically pre-filling it like all of these things are there, and all of these things are available here. And we used to do a set difference of it, and we used to find key which all are available, and then we used to move forward. Right? Very simple hacky solution, but it does a good job there. No hiccups, anything. But if you want to do it at scale, you can use Airflow to do it, or using Redis that TTL part. If the payment is done, if the payment is not done, your key would automatically get expired. So once you come back, right? So once your user would no. So once the key is expired, what you'd get is you'd have to somehow understand that these keys were there, but these keys are expired now, right? Once you identify these keys are expired now, how will you do that? You can check these were my available seats. Now, once a while, check out of this thing, how many are booked and how many are in the cache. And other thing, you would be releasing the lock, right? So those things. So basically state management using asynchronous cron jobs is what you would have to use there. Okay. So any questions?
I think one limitation of this TTL thing is it's not 100% sure shot the time at which you want TTL to be done in Redis.
Yeah,
That's what I have
वो
read.
तो कर सकते हैं, वो problem होती है थोड़ी सी, but ठीक है, that's fine.
I just wanted to add one thing. Like on paper, every system design looks great. I'm just speaking this from Flipkart's actual experience because they had a bug, and like I used to order even after Flash, and I like found a way basically कि वो हो जाता था. I did a lot of orders for a lot of people. तो वही मैं कहना चाह रहा हूँ कि like how much like it gets successful in production, and is there some
नहीं
metric?
होता है, नहीं होता है, नहीं होता है. To be really honest, नहीं होता है. A lot of systems are very poorly designed. At all the places, they're poorly designed. And
Yeah.
the way we are building system is actually the way real companies are actually building system. Right? You try to make it as foolproof as possible, but in production, a lot of things fail. A lot of unprecedented changes happen. A lot of hacks are applied. Even after so many years, Flipkart Big Billion Day is still a big hack. Right. So along their system, few of my friends work there. Then they tell me their stories, and then I realize कि इनका भी hack पे चल रहा है, कहाँ $14 billion है. But हाँ, that happens a lot.
I have a very basic question. If this count is right, so you maintain both the count. How do you switch that? I mean,
how do you?
Let's say regular item is there. One same product item is on the sale, like flash sale, and the same after the sale is over. So actual count, let's say 100. You said it's on sale.
No. That inventory is separate. This inventory is separate. You cannot merge them. Flash sales inventory and other inventory are different.
Oh, you so
total different.
Okay, then it's fine. Okay. So as soon as the flash sale gets over,
यहाँ की inventory यहाँ पे move हो जाती है.
Oh, okay.
Items in flash and regular.
And like while designing a lot of systems, like as in current system का भी बहुत ज़्यादा consideration में लेना पड़ता है ना कि
बहुत
whether it can scale or support the design.
Yeah.
Because we do not have to take any challenges around how our current system is running and if that can be integrated onto the system or not.
Yes. बहुत लेना पड़ता है बाबा, बहुत मुश्किल है. बहुत मुश्किल है. मतलब a lot of time that's where technical debt comes into the picture. Chalo. One final thing for today, distributed task scheduler. So what we would do is we would build something like a Dcron or CloudWatch events. So what we want to do is basically have a global cron sort of stuff. Just say what we want to do is we would want to, basically build a system which would act as a global cron for us, which is a distributed cron. So the features that we want is you should be able to register that I want to run this task at this particular time. That's it. And it should execute at that time. How would you do that?
There will be a task register and then a task runner. Two main blocks, right?
Now what?
So
what would task register do?
Register would hold all the tasks in a queue, probably.
Socho.
Yeah. Okay.
We need to use a backend DB as a source of truth.
Which DB? Or rather, which DB would you pick?
So this will be time series data. So right, time is the key here. So something like what we discussed, like MongoDB or Cassandra, should be good enough.
Let's start with MySQL, because MongoDB Cassandra might be overkill. Because at the end, what we want to do is we just want to find out, see what kind of queries would be fired onto the system is more important to understand. What kind of queries would be required in this in the system?
By time, like for instance, the last instance, what are the jobs we need to trigger?
Correct. The jobs that we need to trigger. So the query will always be by time. So if you just have a normal MySQL database in which you are indexing the column created at or basically scheduled at, that's also good enough.
Yes.
Correct. So your query is mostly like task in next 5 minutes or something like this. So you would have some basically queries like this only. So you can just have one index on scheduled at, and that would do the job. Okay, so you have now registered a task that this task needs to be run at this time. Okay. Now about task running. Now, how would you implement task runner?
Yes, at every fixed interval, 1 minute or 5 minutes, it will do a read on this table and get all the tasks that needs to be run, right? And which are eligible for running, right? And then once we have that list, it will trigger them on individual, probably containerized applications or Dockers or something, right? And then once this is triggered, they'll mark as executed, right? Triggered, sort of, and the SQL, right? So that they are not picked up the next time for the next run. Yeah. So for the initial,
But any limitation at scale for this sort of flow?
Before triggering, we should update the state, I guess.
Okay, let's update the state before. Okay. So that lock is taken on this. Basically, this task is picked up. Do not pick up other.
Okay.
But anyway, this is just one job. So because will you run it or
there might be multiple consumers, basically.
Multiple consumers of what?
Multiple task runners, basically.
So everyone is running this every 1 minute ka task.
So basically, there are multiple tasks, and there might be multiple consumers who checks which all tasks to run. So there might be 2 instances which run the same job. Okay. If we trigger first and then update the state.
Okay. Okay. Got it. So which means your task runners are multiple machines on which the code is running, which is basically doing every 1 minute. It is making the query to the same database, right? And basically trying to fetch it. Now, just imagine how will you write this query, right? You'll be picking the task. No matter when you do update or do the trigger, at the end, what would matter is you would be doing it in one transaction. Correct? It will be one SQL transaction. Right?
First query will be fetching all the tasks, and second query will be updating the state of a particular task. Right?
Will you do it in transaction or not?
There's one more. Can we like, we'll have a task ID, right? And let's say we have task runners like 5 or 10, right? So if a particular task ID, the modulo is output is coming as 1, then this task is called as first task runner. Always, right? That way the task would be always split.
Correct.
But there might be one problem, like a particular task is big enough and it is not getting executed on task 1. So we might want to run other tasks on another instances. Like there might be multiple tasks which have hash 1. So it might went to same task.
We can have like task runners as like as consumers. So as soon as they finish a task, they consume from like maybe a queue or something. So they are continuously running all the time.
Task runner was reading from this database. Queue beech mein aa gayi. So let's see the problem here, right? So here your task runner is the one who is not only reading the task from the database but also executing it. Right. So now if the task is big enough, the other task which was scheduled to be run at the same time, hashing at the same location, will be starving. Correct? Yes, no? It would, na? So 2 tasks getting hashed to the same location or getting hashed to the same task runner might starve, right? Because one of them is running, it's a big running task, but the other task, see here you would have to have here the key constraint is you have a very strict SLA. That let's say I want to run a task at 10:00 sorry, I would want to run task at, let's say, 10:05. Okay, I've scheduled it that my task should run at 10:05. And so which means this has to run at 10:05. I cannot run it at 10:06. 10:06 running is not allowed. I have to run it at 10:05 only. If I want to meet this strong of an SLA, right now, how will I handle the situation? Because now if my task runner is not only pulling the task from the database, but also executing it, other tasks which are queued up to be executed at the same time might be starving. So that's where whenever we are designing this architecture, this is very close to how I built notification ka video, if you guys have seen it, right? So because we would want to like split the responsibility to ensure the minimum SLA by everyone, what would we do is, again, that is a great point of bringing in queue into the picture. So we would have component 1 as a task register whose job is to register the task. We have another component which is a task puller whose job would be to pull the task out of the database and basically find all the eligible tasks from the database and schedule it to be executed. And then you have a task executor. Okay, so task register, task puller, task executor. So what you would have is, you would have some API server which is basically taking in all the tasks. Let's say you have a SQL database for here, and here the task is getting registered. Right now, this is one place where a normal user or your code or someone is making an API call and is registering the task in the SQL server. Then you might have, let's say, one box, for now, one box of task puller, whose job would be to read the data from the SQL and fetch, just pull eligible task and enqueue it. So where it would go is, it would get my task puller, it would get my task from the SQL or basically from my database, and it would add it to a queue. Let's say I have a queue over here. So task puller ne task pull kiya and has put it into this. And now from this task puller ka queue, I have my task executors. So these are my executors whose job would be to execute it. These are the ones who would do all the heavy lifting. So now I can just have one puller whose job is to find all the eligible tasks. So now iska job is very simple. Just fire one SQL query that goes to the database, fetches all the eligible tasks, creates those many SQS messages, and just dumps it. Right now, there would be consumers who are listening from SQS messages and are executing the task. Makes sense? So SLAs maintaining is very simple, because task execution can take a lot of time to happen. Let's say task execution takes 15 minutes to happen, but it would not impact other tasks which are eligible to run at the next minute. Let's say 10:05 and then 10:06 and then 10:07, right? Because executors is different and puller is different. Make sense? Correct?
So here we'll have to have a sync between when the executors will dequeue the queue, right?
Executors are continuing dequeue the queue. They are continuously polling the queue for new messages. They are infinite processes.
Okay. And then they'll spawn a sort of a Docker or something.
Correct. Executor jaisa karna hai. So let's say your executor says that, okay, I want to create a Docker for this, or I want to just run it as is, or I just want to send email, I want to do anything. It depends on the task which is scheduled. Or if it's any sort of trigger, it would just do it.
So, Arpit, from the consumers, like the user's perspective, as soon as the task is pulled, it is started executing, right?
It has started. No. The task has started executing when the executor has actually pulled it. So you'd have to, you'd have to keep check of the metric, that how long is the delay over here. This is the key metric that you'll have to keep an eye, that how long it took for your task to be first put into the, so once the task is put into the queue, how long it took to be dequeued from it. Right? This is a very key metric that you would have to that you would have to ensure what's the maximum delay that you are seeing over here.
Based on that,
Based on that, you would be defining your scaling.
Yeah.
Right. Yeah, Varun.
Let's say I have configured a rule which says that run the task every 10 minutes. Okay. So the puller will go through all the such rules, and let's say it is scheduled to run every minute. And every
so that is so basically what you are talking about is a typical cron syntax. जिसमें you just define one rule which says you are execute this task every 1 minute or every 10 minutes. And how would your puller understand that?
Yeah.
Right. हाँ, उस पे आते हैं. So I'll make a note about cron syntax and how we can handle it. Right. उसमें मैं आता हूँ. मतलब बहुत simple सा है, but उसमें मैं आता हूँ थोड़ा. ठीक है. So yeah, so यहाँ पे executors are there. Now my question is, what would be your tech stack for executor?
That Amazon service.
आज ही discuss किया. At the start of the session I discuss किया.
अरे Amazon का उनका सर्विस है ना on demand.
Lambda.
What? Lambda.
Right?
Serverless functions.
नाम याद नहीं है.
Because that happens, right? So we were discussing about DynamoDB streams. Okay, you other guys might not be there. We started classes. So me, Varun, and the people who joined before, we were just discussing about DynamoDB streams. So DynamoDB streams you can configure your triggers as Lambda functions. So whenever you can configure the trigger of the Lambda functions as SQS messages. So whenever the message is pushed into SQS queue, your Lambda automatically will get triggered for that. Right. And then you would have one generic handler which would understand the task and then basically spin up another environment, maybe a Docker or maybe something job offer stuff, whatever it has to do, it would do it. Imagine where can you use it? Like if you're building lead code, geeks for geeks or online code judge, this is exactly how you do it. Right. You would have a task below. Whenever someone submits the job, it adds into the queue. Whenever it sees that message, it would spin up a containerized environment and execute the message, or basically execute the code alongside the test cases. Right? There are so many use cases of this. So that's why separation of concern is a very key thing over here. Your executors should be different, your puller should be different.
Yeah, I understand that, but I mean, Lambda has its limitations, right, on the time frame. So maybe a containerized environment.
Maybe containerized environment, maybe some n number of pollers that you would want to use. You can do that. Like, but at the end, the key metric that you would always have to keep an eye on was the delay, that time when the message entered and the time when it got processed. Ye wala tha. This has to be, so this is something that would define your SLA. And if you're saying that your SLA is 30 seconds, that within 30 seconds, if your task was scheduled to be run on 10:05, it won't be 10:05 30 seconds के बाद में वो कभी मतलब उसके पहले execute होगा. Right. So if you're having that SLA, you would have to keep an eye on this metric, delay wala. Okay. Yeah. Any question, Amrish?
I have a very hypothetical question, though it will work. I understand, but it's let's say I have like multi-tenant scenario and I want to maintain separate queue and separate set of executors.
तो बुक कर लेंगे ना. ऊपर SQS queue, SQL database अलग, puller अलग, ये अलग.
So
same infra.
So you will duplicate the infra.
Yeah. Because it's multi-tenant, so उनका data भी will be kept totally separate.
Okay.
Okay. Chalo. Now coming back to the interesting question that Varun asked, what about cron syntax? Like how do we even handle this part, right? This is a very fun situation because in cron syntax, what you can configure is, I want to run my task. Let's say I want to run my task every minute. So I can write just this thing, start. So this would configure my task to run on every day of the week. Or no, so for every hour of the week, for every minute, for every hour, for every day, for every month, for every year of the week. Which means basically every minute run karna hai task ko. So how can we build a system like this? So one very simple way to build a system like this is you need to have a machine, which is a populator. So the job of the populator would be to go through all the cron syntaxes which have this sort of syntax, not exactly start, but any sort of, which is not just a one-time activity, which is something which is repeatable. Go through this and make the corresponding entries in the SQL table, right? So यहाँ से on this database it would go. So maybe a database or a table in which you get the fixed time interval at which the task needs to be executed. So from a generic looking syntax of a repeatable task, we will create, or we will basically fan it out into those many entries into my database for each of the corresponding time interval. So if you have used AWS and when you schedule a cron expression, you would see that it basically gives you like next 10 invocations of the functions ka time niche mein, right? So when we were designing a very similar system to this, we exactly built that. I'm yet to go into any tool that implements this. I found a couple, but I'm yet to go through any tool that implements this. But yeah, this is what I would do on day 0. Maybe something else on day 1, but a day 0 solution would be this. So to formalize it, what I would have is I'd have a populator ka dabba running, whose job would be to read the data from my task registry. And now this task registry में पूरे repeatable task कर दे. It will take all the repeatable tasks, or rather it would have all the tasks like this database only, our SQL storage that we have. Right, this one storage in which task is registered. And now here, what it would do is it would add it to another database. Let's say another SQL database जहाँ पे absolute execution times है. So यहाँ पे there are relative times. यहाँ पे absolute times.
Yeah, it
And
will be
this
similar
is
to
what
our
यहाँ से
recurring.
वो जाएगा puller के पास. Oh, sorry.
Yeah, it will be similar to our recurring meetings, right?
Yes, basically recurring meetings. Exactly that. So it would basically continuously add those many entries into it. So absolute. So from relative time to absolute time, and then your puller, and then queues and all and other stuff comes into the picture. So that's a day 0 architecture. Might not be very optimal, but a good day 0 solution. So run this job once a day, populate all the tasks for the day. And let's say you change your mind and you change the rule something, you just go back and edit all those entries. It's a very simple thing to do.
Actually, Quad does the same thing. It creates triggers actually. If it's a cron job, so apart from the job entry, there will be multiple triggers created in the DB entry. So I'm not sure, like it creates 10 at a time or something, because it doesn't make sense to create all the triggers.
Exactly. All ka nahi kar sakta because it's infinite, right? You would just create one for the day, and then baki next day, something like this.
Yeah. Maybe some puller who is doing this check and
exactly. So so you would have a populator job who is reading the repeatable task and basically making it absolute, and then which is being consumed by a puller service, and then it moves to the queue and then an executor service.
Yeah. So basically, maybe there is one is simple. Generally, Quad does is simple trigger type and cron trigger type. So from that, it makes out that what kind of job is that, and then trigger it populates. Maybe when it pulls right while polling, it populates the next 5, something like that.
So you can even do that. So either do it once a day, or when the task is executed, you will populate the next job. So because when you're doing that, you would know okay, this belongs to this relative rule. So basically populate the next 5, something like this. So depending on what, you might have a populator service who is doing that, who is making sense of absolute time from the relative syntax that you have. Okay. So one final thing before we conclude today's session is about scaling things. We just had one database, one puller, one executor. A very simple way to scale this thing up is shard your database, have those many pullers running, which puts the data on those many queues. So create just separate parallel infrastructure which is sharded, like this entire thing. This entire thing would be sharded, right? So create those many partitions of it. So depending on which database it goes to, it would go to the corresponding puller, would go to the corresponding queue and then executes. You can do that. So if you want isolation, you can do it as a multi-tenant split, or you can also do it as a split at this level where like your one database is not able to handle this much of load, which is anyway not going to happen. But if you're not able to handle the load, then you can do multi-tenancy or partitioning around that database. But if you are unable to scale your executors here, then you would have to have multiple queues. Right? This is very important. Let's say you are bombarded with a lot of tasks, which means Puller is creating millions of entries. So your delay would grow very high, right? And there would be a limit on number of consumers that you have. So what you would do it is you would at least partition, you would have to at least partition this much of part. So add one more queue. So Puller pulls a task from the database. From it, it would then put it into first queue or the second queue, when then it would be picked up by the executors. Right. So this is where you would want to make a change if you want to make the change in the executor part of things, where your execution is becoming the bottleneck. If you're pulling is big, or if your task resistant task pulling becomes a bottleneck, then here is what you have to optimize for things. Right. And yeah, this is a very naive-ish, basic-ish looking solution to do a distributed task scheduler with a fixed set of SLA. Through this, you can measure the SLA.
So if you have multiple queues, how the executors will partition themselves with queues?
No, executor alag chalenge. A few set of executors will listen to this queue, few other set of executors will listen to other queue.
So you will do the binding of the executors?
No. So all executors are independent.
So let's say there are 100 executors. You have 5 queues.
No. I'd have each queue pay 20 executors are running. I'd be having configuration. So my executors, whenever they'll boot, they'll find okay, I am, so my affinity is towards this queue.
Okay. So
right. because you cannot have an infinite fan out from your message broker. Because वहाँ पे भी number of concurrent workers to an SQS queue is limited to some number. It's close to around 200 or 1000 something. So उतने ही max हो सकते हैं. After that, it basically does not allow anyone to poll. It starts raising exceptions. So it's not infinite fan out possible. It's not there.
So Puller should also know the which queue it has.
Which queue? So वो partition normal hash based partitioning. It would put to this queue or this queue. Or you can even have this thing that if my task is of high priority, I would have one queue. If it's of medium priority, I would have second queue. And if it's a low priority, I would have third queue.
So can't we have just rather than binding, we can have consistent hashing based on queue and the.
That's an overkill. Why would you want to have consistent hashing?
No, so let's say 10 queues are there and 100.
But what if you would want to have severity wise split? Like let's say something which is submitted to a high priority queue will execute within 15 seconds, medium priority per 30 seconds, and low priority per within 1 minute.
Then yeah, it makes sense to create different kind of queues, right?
Yeah. Because at the end, the cost for this system is very nominal because message broker is charged on demand. Your Lambda functions are on demand. Even if it's a stateful workers, those instances are fixed price. So you can even scale up and scale down depending on the messages you have. So you are typically not paying anything extra. You are just paying for the computations that you need.
Okay.
So even money is not concerned.
So basically, how will this get configured? Like 5 queues and different workers. So how will it in real production will scale? Let's say you want to add another kind of queue and another set of.
I'll create one queue, provision the workers to it, right? And then make an entry into my Puller code where I'll say, okay, instead of 4 that you had, there is one more queue which is part of it. So instead of doing a mod 4, do a mod 5.
Okay.
And if it's a priority based queue where I say high, medium, and low priority, it would be there given with the task that is submitted.
A task type, whatever.
Right. So उस पे task type पे वहां से आएगा, and then it would be scheduled on that corresponding queue.
Okay. Okay. One thing I would like to ask. Okay, this is configuration. You are not going to do every time. So once a while, it will be like you will configuring one queue and executors. So one scenario is, let's say you have all this deployed and it's at a very high scale. So you want to spawn a service, right? So how generally in case of Kubernetes and Docker, it knows that what is the configuration of the service and it goes and registers itself when it responds, right? So in case of let's say we don't have Docker or something like that, somebody can ask if you don't have Docker and you don't have Kubernetes. So in that case, if I have to design, I should maintain the service configuration and resource manager, right?
What service configuration? What are you storing there as a config?
What I'm storing, I mean, the kind of service, let's say, just like Docker, we have the image information.
No,
If
but what are you storing here? For what?
storing
For
the-
executor.
let's say this some service is there. So what is the executable code? Where is that? And if I want to run
हाँ,
time,
वो तो रहेगा ना. That has to be stored with the task, na.
no, I'm not talking about scheduler thing. I'm talking about general perspective. Some service is there, and automatically we want to scale. And let's say we got some health checking and got to know that.
No, but I'm still not getting the problem. What kind of configuration do you want to store?
Configuration in the sense that machine which I want to increment the number of replicas or instance.
Which
right?
puller or
Yeah, any one of,
or executor?
any one of that. Let's say.
हाँ, वो तो एक resource manager में डालो or maybe some database in which you are storing that information.
So that should be done somewhere, right?
Yeah. If you want to make it that dynamic, it has to be stored at a central place.
Okay, yeah. So that's what
Right.
my question. Yeah.
It could be stored Zookeeper, database, DynamoDB, MongoDB, MySQL, any database that you want to store that information. That's a configuration. So you are making a configuration-driven environment.
Yeah.
Right. So वहाँ से चलेगा, but then there has to be someone who is listening onto that configuration,
Yeah,
and if
yeah.
it changes, it makes changes in your environment.
Yeah. Right. Yeah.
Sure.
Okay. Thanks.
If the data puller is the bottleneck, then maybe things like indexes to the DB, those kind of things.
So see, the job of a data puller is to just poll the database, get the next set of tasks that needs to be executed, and just enqueue it. Right. So let's say at a certain moment, let's say there are millions of tasks which are there to be executed. So then your database puller is going to be the bottleneck. So in that case, you would want to partition it. Right. So puller में. So now you added a very nice touch. चलो ये भी cover करते हैं, मजा आएगा. So now what is happening is, let's say you are using a SQL DB. Okay. And what you have is, you have 1 million entries. Let's take this hypothetical situation. Now, let's say you have 1 million entries in your table for the task that needs to be executed the next minute. Matlab, those 1 million tasks are eligible to be executed. Now, what you want to do is, if puller is just one machine, that would become the bottleneck because it cannot guarantee you that SLA. Right. So now how would you do? So basically, then your puller cannot be one machine. Correct? If your puller is one machine, then that would become the bottleneck. So puller has to be multiple machine. But then if you
then that will, because it will fire multiple read queries on the database for the same interval, right? So then you are still kind of moving the slowness to the database because they'll all take locks and things like that.
Correct. Now our job is, without giving up on concurrency, without giving up on throughput, we want to have multiple pullers being able to drive that much of traffic. But how will you do it? We have already covered this, by the way.
Yeah, I think you said partition the database and match the number of.
But even without partitioning, you can do that. Even without partitioning, by just having multiple pullers. And when I said I covered it, it means during the course, not just today. So, yaad karo.
Range-based queries
would not work, because what if one of the machine goes down? वो task schedule ही नहीं होगा कभी. Right? If it's a range-based thing, where let's say I have 10 puller machines, each one of them is like mod 0, mod 1, basically for the 0th index, first index, second index, third index. What if one of the puller goes down? Then वो सारे tasks are not getting scheduled. That's a very poor choice of design there. What's no locks? See, what you want to do is, you don't want to take locks. If you take locks, then you are typically serializing everything. And if you're serializing everything, it means like your transactions, the way you're defining transactions is like, thoda messy ho gaya, because like so many people are trying to do it, so others are waiting unless this enqueues it and then it releases the lock and all. Right? You can do that. You can do that. It will still give you good performance, but there is a better way to do it. And this is exactly what you'll do if you would want to build a message broker on top of SQL. Again, so this solution is nothing but building a message broker on SQL. एक मिनट, let me just थोड़ा सा आगे cover कर लेता हूं मैं. हाँ. So what we are doing is, instead of taking exclusive lock, see what we did study was a shared lock, exclusive lock. So shared lock पे क्या होता है? Shared lock पे it allows other transactions to read the data, right? But it does not allow them to write the data. With exclusive lock, it does not allow others to even read the data. And this is exactly what we need. We don't want, let's say there are 10 puller machines and all of them are trying to read the data, right? Where they would be trying to read those million rows from the database, correct? When they're trying to read those million rows from the database, each one will start from the top and each one will get choked at that point, because like this is exclusive lock. So these are waiting for them to read. So exclusive lock is not an option, correct? Because exclusive lock mein everyone would wait on those first. Let me just quickly, draw, like, let's say I have row 1. Oh wait, I'll say task 1, task 2, task 3. I have task 1, task 2, task 3, task 4, and task 5. Okay, let's say I have 5 tasks. I have 2 puller machines, puller 1 and puller 2. Okay, so what we are discussing is, without partitioning, how can we get high throughput on such systems? Like if you look at this, this is 5 rows in the database, 2 machines running the same piece of code. And what we are actually mimicking is, we are actually mimicking a message broker here, right? It's like only one of them will get, the task, correct? Yes, no? Yes, correct. Chalo. Now the problem is, now we have to address this problem. So the first solution that comes in, because we want exclusiveness, is like exclusive lock. So when we do exclusive locks, what would happen is, writes are not allowed, even reads are not allowed. So when you say reads are not allowed, your other transaction is trying to read. So what kind of query would you fire? So let's say these are timestamps 0, 1, 2, 3, 4. This is your timestamp. Or rather, no, sorry, your timestamp would be, let's say 1, 2, 3. And all of the timestamp is 1, 2, 3. So this task is scheduled to be run at 1, 2, 3, and this is your task. Okay. So the query that you would be writing would be select star from tasks where TS is equal to 1, 2, 3 for what was for exclusive lock?
For update.
For update. Nice. Now, when both of your puller machine would run this query, what would happen? The first puller would have run, and obviously what you would do is like, for update ke pehle, let's say a limit to and for update. So each puller just picks 2 tasks out of it and executes it, right? So 2 tasks and then enqueues it, 2 tasks and then enqueues it. Okay. Now what would happen is, both of your puller machine is executing the same query. Both will start from the first task, then second task, because it is ordered. It will pick from that. So what would happen is, we're taking an exclusive lock. When the first puller has read row 1 and 2, the second puller is waiting, because the first puller has not left the lock. Once first puller leaves the lock, it would read 3 and 4, and then the first puller will wait. Right? So exclusive lock is not an option. Correct? Make sense? Makes sense. Then what's other option than exclusive lock? Exclusive lock ke alawa other option is shared lock. So shared lock pe writes are not allowed, but reads by concurrent transaction is allowed. What's the syntax of shared lock? What do we write instead of for update? Batao.
Skip log something.
We write for shared. Yeah, just why is it zooming? For some reason, this is zooming. Copy. Wait, okay. I'll just rewrite this entire thing. So for shared log, what we write is we write for shared. Okay. Now when we do this, same query is being executed by what? Puller 1 and puller 2. Now what would happen is puller 1 has read task 1, task 2. Puller 2 will also read task 1 and task 2 because reads are allowed. So neither exclusive lock nor shared lock would work over here. Okay. Shared log is even worse because it is allowing read to happen. So exclusive log is still a better solution here because we want exclusivity. But now now comes the must point. What we want to do is we want to read the logs. We want to skip the locked rows. Correct? So what do? We studied about no wait and skip locked. Right? याद करो database वाला week. We read about no wait and skip locked. Correct. So you can just use exclusive lock with skip locked rows wala part. So no wait is something that you don't want to do because no wait would say that I don't want to wait for this and just terminate my transaction. But skip lock would say that if when I'm executing this query, if for this query, if these locks are if these rows are locked, skip them and just continue to search in the database for other rows that match this where constraint. So through this, what would happen is my first puller would have read task 1 and task 2 would have taken exclusive lock on that. When my second puller would come in, would fire the same query, it would see that first 2 rows are locked. It would skip that and it would find other rows which have matched the constraint. So it would see skip lock. First 2 rows are skipped for it and third and fourth rows are locked by puller 2. Yeah, Varun?
I mean, I don't agree with it because let's say there are 2 pullers. The first one read and is done. I mean, it just put it in the queue. I mean, there is a slight difference between the 2. And the first puller got all the records and it just put it in the queue. And later the second one came and it just got and put it in the queue. So, I mean, ideally there is a duplication in this approach.
No, because you would also do this, na? Baba, you would also do an update, na? So, pura query likhu kya? So, यहाँ पे you would have a property, na? State or something, which would say picked or not picked.
Okay.
मतलब यार, Varun यार, ठीक है, something like this, and then you would apply where clause over here, and state is equal to not picked. Right? अब बताओ. Now any more concerns? You'd have this thing, na? Because like you'd need to know ki this task was picked by whom. Right. So maybe you would have not picked by default on all. Maybe 0-1 is the better. Obviously 0-1 is the better way to do it, but just adding it over here to make it more verbose.
Okay. So basically you repeat this with limit 100 till there.
Just a minute, my audio device. Yeah, my speakers died. Oh, continue recording.
Yeah, it's
recording. Yeah, am I audible?
Yeah, you are audible. You are audible there.
Okay. Just give me a minute. My headphones died out. Yeah. Am I audible?
Yeah.
Okay, fine. So, Varun, you're saying.
Now it makes sense. I mean, so you repeat the same query with limit,
Yes.
maybe a number, But how do you get the end? I mean, when do you know that it's the end?
And so it would find now, because your puller would find that now there are no tasks that matches it, so it would kill off the process. And it would basically stop doing that.
Okay,
Because
when there are no results.
yeah, when there are no results, it would stop doing that. So if you see, this is exactly what a message broker is, right? Exactly once delivery, you have multiple consumers listening in the message queue, and only one of them is like allowed to read a particular message. So exclusive lock with skip lock is what the secret sauce is. So we just designed a message broker on top of a SQL database using normal SQL construct, nothing fancy. Fun? Chala. Any questions? Chala, it is already late, but anyways, Chalo. Yeah, basically that's all I wanted to cover. It was a very fun discussion. We discussed like 4 really weirdish problem, but alag tha, ad hoc system design. A little interesting, and we covered a lot of interesting stuff there. So we just built a message broker on top of SQL database, and यहाँ पे task registry scaled up this thing, splitting responsibility, वो वाला part हो गया, and यहाँ पे with flash sales, locking and all. Here also, when we are taking a lock, atomicity, stressing on the property, we can use optimistic lock, we can use pessimistic lock, whatever we want. Optimistic lock is much better, but all we seek is like atomicity to get those things done. Physical representation of a virtual thing, like actual ticketing. Physical ticketing is something that we can use over here to like ensure atomicity. So if there is already a managed service available that is giving us atomicity off the box, we can leverage that. That's what I wanted to throw light on. YouTube use count, we had a great discussion around it, and ClickPass. Quite a bit. काफी कुछ cover हो गया अच्छा. Nice. चलो. My daughter is there. Chalo. Any questions? Otherwise, you can close this off.
I think one out of the out of this. So have you like ever migrated in any of your experience from like your own EC2 instances to AWS Lambda and saved on like significant?
A lot. I did about a year and a half back. I built a notification system. We were using EC2s, but then we moved to AWS Lambda, and we literally saved 70% of our cost. Because our notifications were spiky. It was burst in nature. So we did not have to over provision. So typically when you save cost on such part is when you do not have a consistent load in your system. When your load is spiky, and so through this I was not over provisioning my data structure, or I was not over provisioning my infrastructure to be serving scale at all the times.
Got it. Yeah, like we have used notification AWS Lambda notification systems, but I was never in the place where I saw that migration.
Yeah,
so
I did that, but बहुत पता है.
Thanks.
Awesome. It was a really fun discussion for me. I hope it was is always there. अरे यार क्या होगा? Default microphone. So sorry, my mic is getting changed for some reason. Output and input. चलो इस पर आगे. Yeah. In case you have any questions, feel free to ping me. But I hope I covered a lot of interesting topics today. I'll still float the message for feedback and testimonial. Please write that stuff. And next week we'll be covering algorithms. We'll be discussing really fancy algorithms. Tender Bloom filter will be revisiting once again, and few more. Right? Some online algorithms, some approximation algorithms, heat maps, and all. And I'm planning to add 3 or 4 new things to that, and we'll cover that next week. Awesome. Thanks a ton, guys. See you guys next week. Bye bye.
Thanks.